recording has started. If anybody of your friends have still not joined in, so the limit for this class is going to be of 300. If you don't join in and the limit exceeds, in that case, sorry, but we won't be able to accommodate any more students. So this is it. Let's just start off with the class, and let me just take a quick picture that we are starting off, and boom. So Assalamu alaikum, everybody. I hope you all are doing super duper well. Just for those who might not know me, I am Muhammad Maaz Munir. I got a top in Pakistan distinction in Igcse Computer Science back in 2023. Okay. And the thing is, I just completed this whole thing very alongside, not a very long time ago. Okay. So I was the one who gave this exam back in 23 with the newest syllabus. So I'm fully sure of what has to be tested on the exam and what not. The purpose of today's class was to give you guys a quick recap of what paper number 2 is, so that if anybody of you has any sort of questions regarding paper number 2, we can address all of them. So starting off, the most fundamental question which almost everybody asks again and again, guys, just give me 1 minute. I need to send one message and then we can start off. Just give me 1 minute. Okay. All right, so one of the most common questions people again and again ask is, okay, so people generally ask this question, sir, do we need to know any sort of programming language? Because paper number 2 is supposedly a programming paper. So would this mean that I need to learn programming language? No. Please, if you're someone who might be just starting off or is in this scenario that, okay, we are learning programming language, I would recommend you're not required to learn any programming language, because the entire pseudocode, chapter number 7, chapter number 8, or any programming question can be solved with pseudocode. What's pseudocode? We're going to discuss that later on. But your paper number 2 is basically divided into 3 major parts. One is the pseudocode one, where you learn the programming aspect of it. This basically discusses chapter number 7, chapter number 8. Then we have the databases, which is chapter number 9. And finally, the logic gates, which is chapter number 10. Now, relatively, also, a lot of you students would be able to find these 2 topics to be very easy. I know you won't be facing any problems with them. The biggest challenge in paper 2 comes up from these 2 topics, and this basically makes up at least 75% of your paper. So it's really important that you understand all the concepts in great detail, because if you don't understand chapter 7 and chapter 8 content in great detail, the problem is that you will not be able to solve those easier questions. And for anybody who is thinking that I'm unable to solve the 15 marker, the biggest problem why, or the biggest reason behind why you are unable to solve that 15 marker is the fact that you all do not ensure that your concepts for chapter 7 and chapter 8 are clear. You are unable to solve those easier questions. How do you supposed to solve those difficult questions? So today we're going to go through the basic concepts once again. So for anybody who might have those basic challenges or questions in their mind, we're going to try to cover all of them in great detail, inshallah. I'm going to take it a bit slow. Also, because there are no questions, just the way I mentioned earlier, if there is any question, write it down with yourself. You can ask it later on in the group. Please, I would appreciate if you don't DM me directly, because I'm really bad with responding to DMs. I even at this point have, I don't know how many, some 190 or 200 leftover DMs, and I'm unable to respond to them, given them I'm really very busy, not only up here, but in university too. So 236 what do you call it, unresponded chats. So really crazy, right? So use the group. I do reply in the group. So let's start off. So Bismillah ar-Rahman ar-Rahim. The first topic of your chapter number 7 discusses the algorithm design and problem solving. So when we start off with chapter number 7, the topic name explains some really crucial stuff to us. It says algorithm design and then problem solving. People generally correspond to this topic and they say that it's related to programming. It's not programming. It's basically a topic where you're designing algorithms and then you're solving problems. But majority of the students, unfortunately, are not even aware of what algorithm is. So we're going to start off with the discussion of what an algorithm is. Algorithm is a computer science word which basically tells us the steps to follow to ensure a specific problem is being solved. Which means that this chapter number 7 is basically telling us that, bro, how can you basically define the steps to solve a problem? And what could be a problem? Anything. Like, for instance, I'm trying to create a clock app. So if I'm trying to create a clock app for my phone, it's solving a problem that, okay, I cannot get waken up at like early time. So I have a clock which automatically wakes me up. So it awakes me That's one problem which a clock app solves. Just like that, I have a calculator. What problem does a calculator solve? A calculator solves this problem of complex calculations. So whatever we have right now, even this Zoom platform which you guys are using at this point, Zoom is solving the problem of this scenario where I'm sitting up here at my university. Right now I'm in Lumps, right? And you all are sitting at your respective homes in front of your table, at your table. A lot of you might have their juices with them, maybe some coffee, someone might be having their lunch or whatsoever, but we aren't physically in front of each other. So it's solving this big problem of that I don't have to gather all of you at the same place. And that's a big problem being solved. So this topic basically teaches us that if I have to solve a specific problem, which comes under the problem solving part, what are the possible ways in which I can design a solution to that? And the steps which are followed for the problem to be solved, that's known as an algorithm. So in my classes back for the May, June 2026 series, I gave my students this example of how you can basically make a burger. So for instance, if I have to make a burger, I'm going to grab buns, I'm going to fry the chicken, I'm going to toast the buns, I'm going to apply mayo and stuff, I'm going to put the chicken inside it. And then of course, I will be basically assembling the burger. And if I have to follow these steps, this eventually gets me to my final result of creating a burger, right? That's pretty much evident. But these steps which I need to follow, these steps are what we call as an algorithm. So you see, these steps are what we refer to as an algorithm. So in this chapter, we're going to see that if a problem is given to us, what are the possible ways of creating an algorithm to it? And you should be aware that when we want to create an algorithm, before that, we need to follow a few steps. And those steps are what a programmer generally follows whenever they want to basically solve a big problem. And those steps are known as program development life cycle, or PDLC. So program followed by development life cycle. Now, let me tell this one thing to all the students out here. You generally correspond and say that paper number 2 is all about programming. But let me tell you, chapter number 7, start, has a lot of theoretical concepts too, which usually gets tested in those fill in the blanks, or maybe encircle the question, correct answer, or maybe tick the correct box. And students miss upon this. I remember when I was preparing back in 2023, there was a question on abstraction. And literally, many people were not even aware what abstraction was. Why? Because that was from a theoretical point of view. So it's really important that you always open up the syllabus for whatever subject you are appearing in. Open up the syllabus and review what part of it is left, what part of it is not left. Okay, so just give me a minute. Yes. Okay, so for that reason, we're going to start today's discussion with the theoretical part of chapter number 7. So for instance, my page name is what? It's Code Catalyst. So for instance, if I decide on creating a mobile app for my platform, where let's say the students who register with me, they can basically get the chance to learn directly from my platform. What will a programmer do? A programmer would not be like, okay, like generally we assume that a programmer just wakes up, he's like, okay, I woke up, now let me get a coffee. He gets that coffee, maybe he gets some protein bar in his mouth, and then he comes up, sits on his table, and boom, he starts coding. But in reality, that's not what a programmer do. A programmer always needs to go through a specific set of stages before creating the final program. And these stages which a programmer needs to go through, those are basically known as the program development life cycle, which has this short form of PDLC. Now, if ever in exam they ask you what's PDLC, you should be able to tell what it is. And PDLC basically consists of 4 stages. Those 4 stages includes analysis, which is my stage number 1. Then it includes design, which is my stage number 2. Then it includes coding and iterative testing, which is stage 3. And finally, stage 4, testing. And of course, sometimes they also include a stage 5, but this isn't something which has been explicitly mentioned in most of the cases. But still, to be on the safer end, we're going to discuss all the 5 stages. So what does each stage tell us? The first stage, whenever I have to solve a problem, whenever I have to create an algorithm for a problem, the first thing a programmer needs to do is that they need to clearly define the problem. When I talk about defining the problem, this basically means that I need to tell what are my requirement specification. So for instance, if I'm developing an app for Code Catalyst, definitely that application needs to have some login portal for the students who have registered with me. It should have a section for my students to watch the lectures. It should have a place where my notes and resources are accessible. So these are my requirements. When I'm doing analysis, I'm going to be defining the problem where in a way I would be focusing on what matters. So if I'm creating a code catalyst app, I don't need a platform like Instagram within it, right? I don't need a social media platform where students can, let's say, share pictures with each other. So what I'm going to be focusing upon is that what does my program needs? So this aspect of where I focus on what matters, this is basically known as abstraction. And this is something which has been directly asked in a question in paper number 2. They say, what's abstraction? So you need to tell them that abstraction is basically the concept where you focus on what matters, or you basically divide the problem into smaller chunks where you're literally just focusing upon what matters, or you ignore everything which is irrelevant. This concept is known as abstraction. And likewise, you have decomposition. What's decomposition? So decomposition refers to breaking the problem into smaller parts. So for instance, if I have to make a whole app for code catalyst, I will be breaking this into smaller chunks. How will I be breaking this into smaller chunks? So maybe I might break it into this section that, okay, bro, I need to create a login portal. Then within the login portal, there are two issues. One is that what if a person is new student? What if he's already registered? So and likewise, if a person logs in, then how can he access my lectures? How can he access my notes? So I'm going to break the bigger problem of creating an app into smaller chunks. And then as a programmer, I'm going to first do coding for this, then I'm going to do coding for this, then I'm going to do coding for this, then for this, then for this. And eventually, I'm going to join all the codes together and I'm going to compile them the way we studied in the compiler topic back in paper number 1. And this will eventually give me a final application. Now, this concept where you break the larger problem into smaller chunks, into smaller parts to ensure that we are focusing on what matters, that is known as decomposition. And together, decomposition plus abstraction basically ensures that I, as a programmer, are only looking upon what's the requirement for creating a program. And if I have to even further summarize this, it means that I'm basically defining the problem, where I'm only focusing on what matters. This is what we do under the analysis part of the program development lifecycle. Once a programmer has completed the analysis part, he gets to the designing part. Now, many of you would be thinking that if I'm learning, let's say C++, a programming language, or maybe Python, the moment I'm done with defining the problem, I'm going to just jump and write the code. But it's not that way. What you do is that whenever you create a model as to that, okay, I need to do this requirements. So if you open up your 15 marker, you're going to see every time a 15 marker has a few requirements stated that your program should do this, and this, which gets you a lot of marks. More of this 15 marker stuff will be discussed in another class. Don't worry, inshallah. But just know one thing, that when we talk about this problem or these requirements being solved, before jumping into writing the code, I'm always going to be first designing it, which is the stage 2 of my program development life cycle. In the designing part, what happens is that we basically decide upon how to solve the problem. Or for instance, I sort of create a roadmap. What's a roadmap? You do this first, then you do that, then you do that, then you do that, and eventually you get to the final answer, or when eventually you create the final program. So for instance, if I have to create a design step for, let's say, creating the burger, which I said previously. So what were my steps? I'm going to get some buns, then I'm going to toast them, then I'm going to add chicken, and finally I'm going to eat it. So those are my steps, right? So this steps evaluation, that as to solve a problem, how will I be basically going through it step by step? The purpose or the method behind that is what we call as design. And now there are 3 ways of designing your program. People generally are not aware of this. I'm not sure if your teachers have ever taught you this, but there are 3 ways of designing it. And those 3 ways include pseudocode, flowcharts, and structure charts. Now, I know you all have studied all this, but did you all know that these 3 correspondingly basically complete the designing part? So if I have to design a program, I can either design it using pseudocode statements, which is basically English-like statements, right? The one which we generally use. Or we can do it using flowcharts, where I'm going to make shapes and I'm going to connect them using arrows to indicate what's the flow of the model. And I can create structure charts. What are structure charts? Structure charts are basically, oh, there are reactions coming up. So guys, if anybody of you wants to, what do we call it, disturb the class, I would appreciate that you don't, because if you don't want to study, that's something, then you can leave the class, okay? But there are people up here who want to study. And if they want to study, then I want you to kindly stop yourself from doing any such things, okay? I would highly appreciate that you don't become that attention-seeking guy in the class, just by ensuring that you will get the attention. Bro, it's literally not fun at all. And let me just turn off the stickers feature. Just a minute. Select settings. Okay, just a minute. Emojis. I would appreciate if you don't do anything like that. Please don't try to ensure that people who are here to study won't disturb. I would appreciate great. Okay. So back to where we were. So one way is to do pseudocode. The other is flowchart. And then finally we have structure chart. What structure chart is that we are aware, okay, pseudocode is writing those code. Flowchart is basically creating this step-by-step interpretation, whereas structure chart is that model where what happens is that you write a bigger category, and what you do is you break that into smaller chunks. So for instance, if I'm creating an alarm app, I can divide it into, okay, maybe setting time, I can divide it into checking time, and maybe I can divide it into play sound. Then I can maybe write code for this, I can write code for this, and I can write code for this. So what I did was that if I generally want to create an alarm app all the way from scratch, it's very challenging for me. As to I might not understand what should I be doing. But the better approach is that maybe I will be setting the time. I'm going to divide the problem into smaller chunks. Then one programmer, let's say if I'm creating an app, I can deal with this. Maybe Huzaifa Khan might do this part and Ahmed Anwar might do this part. And then eventually all of the three programmers will combine their code. This will give his code, this code, and this code. And eventually we're going to have the alarm app created at the end. This model of representing how to solve a problem basically comes under the structure chart part, right? Then moving on, the third stage of the program development lifecycle refers to coding and iterative testing, which basically means that you now at this point, once you have finalized what the problem is, once you have created the model as to what steps will I be following, now it's the time I grab some actual programming language and I start coding it. So at this stage, I might be coding in, let's say, Python, in C++, C#, or whatsoever, right? I'm going to do my coding at this stage number 3. But what I'm going to do is that as a programmer, whenever I'm going to do coding, the purpose behind or the perfect way of coding is that I'm going to write a few statements and then I'm going to test it. So for instance, I won't be waiting for the entire program to be written and then I'm going to be testing. What I will do is I'm going to be like, okay, I wrote 10 lines of code. Let me test if there is any mistake. So I'm going to write 10 lines of code. Then I'm going to run it. I'm going to try to see what's the output. If there are any errors in it, I know my compiler will tell me an error report. If there are any errors in it, I will be basically fixing the errors then, and then I'm going to continue. So the way programmer writes a code is that they first of all write a few lines. Then what they do is after they wrote those lines, they're going to test it. And when they test it, they're going to get a report whether there are any errors or not. If there are errors, they're going to go and first fix those errors. If there are no errors, then they move on to the next part. But if there are errors, they won't go and continue coding. They're going to first fix those problems. This concept of where you basically write some code, part of code, then you test it, and if there are errors, then you fix it, and then you again test it to see if there are any sort of an errors. If there are no, then you move on. But if there are still errors, you still go and test it again and fix those problems. This is known as iterative testing. The word iterative generally means repetition. So you would have seen that when we talk about loops, later on in chapter 7, loops is basically an iterator. Why do we say that it's basically iterator? Because it repeats itself. So iterative testing basically means that it is something where the testing is consecutively being repeated one after another till the point where everything has been fully fixed. So the third stage of program development lifecycle includes this concept where you write the code, then you test it, a part of code, and then if there are problems, you fix it. If not, you again test it, and this way you basically write the entire chunk of code. Okay, so you're done with writing the entire code. So what we do is, if I have this much code, large program, in that what you will be doing is you're going to just take a part of it, you're going to test this, then after that you will be again testing another part of it, then again another part of it, then again another part of it, and so on. You're going to test all the small 5 line code to ensure if there are any problems, you can fix them before you complete the entire program. And once I have done this, I'm going to combine all the codes together. So, okay, I'm going to combine all the programming codes at once. And then finally, at the end, I'm going to test the entire program with different types of data. So for instance, if my program is a calculator should only be adding numbers, right? So it should be like an integer value. then multiply by, or let's say any mathematical operation, let's say plus, minus, multiplication, divide, or whatsoever, but it should only deal with integer values. So if I put in something like a string, some character like a plus b, my calculator should be giving me error. So while doing coding, I will be always testing my program with different types of data to see, does it do everything according to the plan? If it does not, this means I might have missed some part. Maybe something went wrong. Maybe something is not according to what I need. In that case, I'm going to fix it. But if it's good to go, perfectly fine. And finally, once I'm done with testing two, I'm going to do the maintenance part. What's maintenance? You would have seen that if anybody of you has an iOS, some Windows, or like even the Android OS, every year you get new updates. So like iOS currently might have 26.3, maybe 3, 4 months after that, you might get 26.4. So even though it's the same version of 26, what does this 4 include? What does this 4 and 3 means? This basically means that after releasing an application, if there is some sort of bugs being reported, like every time a new operating system comes up, there are problems inside them. There are bugs which we as users tell to Apple or tell to these companies that, bro, there is this problem. So when you report these errors, what happens is that programmer then sort of fixes those errors. So now the newer version, which they basically introduce after including those fixing or newer features or any new thing which I might want to include in the newer version, when that is launched over the existing application, which I might have launched on Play Store beforehand though. So when the newer version comes up, this newer version coming up and replacing the previous application comes up under the maintenance part of the program development lifecycle, which is my stage 5. So these are the 5 steps which generally are included in PDLC, but the majority important part of the 5 are basically stage 4, which is testing, coding, design, and analysis. In most cases, you should be fully clear with at least these 4. And for instance, just to be on the safer side, I always recommend my students to be good with maintenance part 2. Okay, perfect. So this marks the end of our first topic, which is PDLC. Now we will be jumping into the problem part, which is basically the main question or main scenario of the entire chapter number 7. We're going to see how do I solve a problem. So always remember, whenever I'm trying to solve a problem, whether it's a 15 marker, whether it's any pseudocode question whatsoever, the biggest challenge is to identify what will be my inputs, what will I be doing upon those inputs, and what will be my output. And of course, in between this, if there is some value being calculated or if there is some answer being fetched out, where will I be storing that answer? So if I have to break a bigger problem into smaller chunks, I'm going to break it into 4 categories: inputs, processes, outputs, and storage. Every time you have to solve a question, see what can be my inputs. See if I have some inputs, what are the processes I need to follow on that? Like maybe do I need to multiply them? Let's say I need to find the highest inside them. Maybe I need to find the lowest or whatsoever. Then what will be my output? And of course, where will I be storing the value? So for instance, I want to store the name of the student who got an A star. Let's say name A star is a variable, right? This is my variable. So if I create a variable like this means that if I have in the question, there is a case that they say that any student who gets an A star, you need to store the name for it. So while creating this plan or before solving any problem, I always need to bring up this point that, okay, do I need to store the value? If yes, do I need to create a variable? Yes, I do. So every time there is a pseudocode question, whether it's a long question, a 15 marker, or anyone, please. I'm also going to emphasize this in the marathon class for the 15 marker, but in the rough work section, try to fetch out these 4 things. It's really important. And now we are going to be jumping into the methods to creating a solution. So the first method which we're going to be discussing is the structured diagrams. What a structured diagram basically does is that it basically shows a top-down design in a diagrammatical form. What is a top-down design? A top-down design is that where you have something finally like the most superior thing at the top, and then you break the bigger problem into smaller chunks. So for instance, if I have to create an alarm app, I'm like, okay, I need to create an alarm app. So that problem can be broken down into set alarm. It could be broken down into, let's say, check time. It could be broken down into remove alarm. Then set alarm could be basically further set into selecting the tone. It could be further broken into what time do I want to set. And likewise, if I want to remove the alarm, I could do it to like maybe turn off the alarm or maybe remove the alarm permanently. So what I just did was that there is a larger problem The larger problem is to create an alarm app. And this larger problem was then basically decomposed into smaller sections. So I broke this bigger problem into smaller ones, such as like setting alarm, maybe checking the time, and of course, maybe removing the alarm. And then if I can further break every smaller problem into even sub-smaller parts, I'm going to break those into further smaller parts. Like let's say maybe selecting the tone or maybe selecting the time. This model where you basically take a large problem and you sort of break it down one by one into smaller chunks, that is what we call as structure diagrams. And these structure diagrams are basically hierarchical. What does hierarchical means? Hierarchical means that every further layer, you are basically having something being divided. So you see, we have one person up here, the alarm. Then that's broken down into smaller parts. Then that's further broken down into smaller parts. So the diagram follows this triangle model. We have something superior at the top, which is the end goal, but we broke down that into one by one method. And now in exam, a lot of people usually don't understand. They complain that, sir, I don't know that if I have to create an alarm app, what do I need to put up here? Now, an advice for you all is that whenever you are given a problem, let's say a problem, first break that problem into two parts. First part should be inputs. What input will you be taking for that problem? And the second should be output. So that's the best way according to what I've observed over the marking scheme. You identify what the inputs are going to be, you're going to identify what the outputs are going to be. And then you might be like, okay, breaking this into further part, and you might be breaking this into further part. Like, let's see, what do we need to do with the inputs? And of course, what do we need to do with the outputs? You also break those into smaller chunks. And that is how you generally solve a structured diagram question. So the general form for any structured diagram is that you have a system, and then you divide the system into subsystems. And then if you can further divide the subsystem into even smaller part, you divide that too. And this diagram which we generally get, this is what we call as the structural diagram, which is something which was introduced in 2023 syllabus, and it's something which examiner can definitely test in your exam, inshallah. Okay, it's an easy question. But let's move on finally to the part which I know have been scaring every one of you out there, and is the reason why majority of you would be in today's class, and that's basically pseudocode. So first, a few pointers. Pseudocode is not a programming language. It's just basically English statements written in some sort of programming way. So you sort of are just writing English statements, but you give that feel of a programming way. Like for instance, I might not be a very, very rich person, but I might get myself a fake Rolex, and I might get myself like some very hi-fi sort of a shirt. And even though that might be something I would have purchased for like 500, but I'm going to pretend that I'm very rich. So people might be like, okay, this is a programming language, but in reality, I am not rich. I'm not a programming language. So pseudocode is also pretty much similar to that. People think it's a programming language. It's not a programming language. It's just English statements, but you write it sort of in a way where it seems to be giving the impression of it being a programming language. The reason why pseudocode is recommended in the 15 marker, if anybody is using a programming language, is that your pseudocode does not follow a strict syntax, which means that if you make some sort of minor mistakes, it's not like you're going to lose marks in that. For example, I gave this one example in the class that when we talk about syntax, syntax basically refers to the grammatical rules which we need to follow to write a programming sentence. Like a lot of you would be using Python, right? So if I have Python has this one way that I'm going to write the print command, and then I'm going to add this bracket, and in quotation marks, I'm going to write the text. This is what we do in Python, right? But if in Python you miss this bracket, the problem is this will be incomplete and you're going to lose marks. But if, God forbids, you make some sort of a minor mistake in pseudocode, that will be accommodated because pseudocode does not have a strict syntax. You can follow multiple other methods too, due to which the examiner is sort of very, very convenient and accommodating with every student who might be preparing a given logic. So if a student is trying to give us the proper logic, examiner will be awarding you with it. Okay, so that's the reason why I always recommend all of my students to go with pseudocode. It's the best method out there. And now, once we know that programming is not a programming language, let's jump into what can a pseudocode syntax statement do, right? So the first part of whenever we talk about pseudocode is that we're going to be first of all most starting off with the mathematical operators. So definitely maths is something really important. In most of the cases, you are always required to, what do we call it? You're always required to do some sort of mathematical function. And this example up here basically shows that what mathematical concepts can you do, and what's the way to doing that. So remember, if I have to add a few values, this is something really easy, and I know you majority of you would be aware. If I want to add two numbers in pseudocode, I'm going to put the plus sign. If I want to subtract them, it has to be the minus sign. If I have to multiply them, remember, if you do something like 2 multiply by 3, examiner can understand this, he might give you the marks, but the proper way to multiplying it is by making an asterisk. An asterisk means that you make a cross, then you add a line up here, or maybe a line up here too. Best, you just make a cross, add a line up here, like this. This basically is an asterisk. And whenever you want to multiply something, this is the proper way according to your syllabus for multiplying values. Okay, so even if you open up the syllabus or even if you open up the marking schemes, they never do something like 2 multiply by 3. They always do 2 multiply by 3 this way. So this sign, which has been given the name of asterisk, which you can even find on your keyboard if you press Shift 8, you're going to see this is what you have to use for the purpose of multiplication. Then, of course, if I have to divide it, I don't have a sign like this. If anybody made something like 2 by 1, this is wrong. For division, you need to do 2/1. Remember this. This is really important. And of course, if you want to do something like raised to power something, so please don't be like 2 raised to power output, 2 raised to power 3. This is wrong. If you want to indicate something raised to power something, you always do it in a way 2, then you put this hat sign, and then you do 3. This hat sign basically indicates that you're talking about 2 raised to power 3. So this is your base. This is what do we call it? The number, and this is my base to which I need to basically, or perhaps that's my base and the other is my power, my bad. And of course, if I have to sometimes maybe group something like maybe I want to do something like 2 plus 5 plus 10 multiplied by 3 divided by 2. So you see, it's very complex. So if I have to tell what needs to be done, first I can add those brackets just the way we normally do in math. So what's happening? It's basically 2 plus 5 plus 10 into 3, then that divided by 2, and then you add the answer 2 plus. So what made it simple? Addition of brackets. So if I want to group something, I can make use of these brackets. And of course, this is how you basically use mathematical operators in pseudocode. Then once we have understood how to add values, how to multiply them, the biggest thing is that if I multiply some values, let's say I have my age. So if I'm like 19 at this point, and there is, let's say, Ahmed in the class, Ahmed age might be 16. So now if I add the two, 19 plus 16, what's the answer going to be? It's going to be 20, it's going to be 35, right? So now it's not like my computer is going to memorize that my answer is 35. I need to store the value somewhere. I need to store the value in some container, some capacity holder, some specific column, some specific place where I can put the value in so that I can later on access it. But how do I assign the value? Or like, how do I basically tell the program that, okay, bro, take this 35 and put this 35 in a variable or in, let's say, an array. What those are, we're going to discuss those later on. But yeah, how do I put the value in a variable? So for that, we have something known as an assignment operator. So an assignment operator is basically a pseudocode oriented function which basically allows you to assign stuff to a variable, to an array, or to any set container. And how do you make use of the assignment operator? You basically make use of this arrow. So for instance, if sum is a variable which I created to store the value of the sum, or I can say it's like a container that stores the value. If I want to put this answer of 8, which is like 3 plus 5, inside this, the way I need to do is I'm going to write sum, I'm going to draw this arrow, which is basically my assignment operator, and I'm going to write the answer. Now my program is going to execute it in a way that it's going to take the value from the right, evaluate the answer, it's going to be 8, and it's going to take this 8 and it's basically going to put it in this sum part. So now my sum will be having the value of 8. Now I know a lot of you up here will be having this one question, and before you spam me with that question, sir, we were always told in the class that we have to do it this way, sum equals to 3 plus 5. This is wrong, guys. This is wrong. So if you were ever told in class that it has to be sum equals to 3 plus 5, that was according to the older syllabus. According to the newer syllabus, according to what was introduced in 2023, the purpose, or perhaps what's the proper way behind that, is that you need to make this arrow. This arrow is my assignment operator. Without this arrow, without this assignment operator, you cannot basically assign a value to a variable. Now, generally, if you put an equals to sign, that is used for comparison. Okay, equals to is basically used for the purpose of comparison. For instance, if I have to, yes, you will be getting, by the way, all these notes which I'm sharing right now, they are available on my website, so you can easily access them. Don't worry. Okay, so if I have basically a scenario like this, and I do something like sum equals to 5, this equals to is basically used for comparison. So if you do something like if sum is equal to 5, then you see this sum equals to 5 basically tells us that is the value of sum 5. So remember, whenever in programming you use equals to is used for comparison. But if you want to assign a value according to the newer syllabus, even if you open up the syllabus or the official pseudocode guide, you're going to see that whenever you want to assign a value in whatever marking schemes you have seen, it has to be this arrow, which is my assignment operator. So next time a question comes up asking about in what line is the assignment operator, look for this arrow. Wherever there is this arrow, in that line, I'm going to find that assignment operator. So yeah, perfect. Now, once we have seen that how I can basically ensure if I have some sort of mathematical operations, how to do those, if I have some sort of assigning of files, how to do those, it finally is the stage where if I want to make a decision, how will I make a decision? Because definitely if I'm making a program, it's really important, right? That I make decisions. For instance, I'm creating an alarm app. So in the alarm app, it's important that I have this decision that if the time which is currently being done, is this time equal to the time or like single equals to the time which is currently. So like if the time which I have set, like, okay, I need to wake up at 7, is 7 equals to my current time, which might be like something like 5:42. Is it equal? If it's not, then you don't ring the alarm. But if it is, like if let's say it's 7 and on my clock it's also 7. If it is, then you ring the alarm. So these conditions where if I have to make a few, what do we call it, paths, and I have to go through where I have to follow a specific route, like, okay, if this happens, I need to go through this way. If this happens, then I need to go this way. And if none of this happens, where do I go? This scenario, whenever I want to represent this in pseudocode, I need to use conditional statements for them. Conditional statements are basically used for the purpose of making decisions between value. And when I have to make decisions, what we need to do is we can basically follow two formats. So there are two ways to implement conditional statements or to basically make decisions. Again, I'm going a bit fast too because I want to cover as much stuff as possible. And of course, this is just a recap class. We aren't like sort of learning it from the base. So I do assume that a lot of you are aware of whatever we are discussing. It's just to ensure that you recall whatever is happening out there, right? So if I have to make some conditional statements, you have two ways of doing them. We're going to discuss each of them alongside an example so that you understand it. So let's say we have a scenario, and the scenario is that let's say we go to a carnival, and then let's say in that carnival there is a ride which has this condition of the age being less than 18. And now I have to make a program to check whether a person will be allowed or not. So I have to write a program where if the person is less than 18, I'll be like, okay, buddy, you are allowed to go. But if not, then I'm going to be like, my boy, you cannot go because you are greater than 18. Bro, please, please. These rides are not for you. Chill, man. It's no longer for you. So there are two ways of implementing conditional statements to ensure that a decision is being taken out. The first one is basically when you implement the if, then, else, and if model, which I know a lot of you usually call as if statements. What are if statements? If statement is basically a method where you tell it that if something is true, if something is true, then you do this. Else, if it's not true, then you do that. So for instance, if I say if something is true, then the condition at this point of true, if that condition is true, then you do something else. If that condition is not true, then you do this. So for example, I wrote this code where I was like, okay, input age, input means what? It takes a value, it gives a value to the computer. So let's say you took an input for an age value, and then I checked that if this age is less than 18, then I'm going to output allowed. So if this condition is true, then I do this part, the output allowed part. But for instance, if it's not true, if let's say the age is not equals to 18, it's greater than 18, which means that this condition happens to be a false value. In that case, I will not be doing this. Perhaps I'll be like, okay, this does not become true. Then I go to the else part. And in the else part, I'm going to be like output not allowed. So if the age is less than 18, you output allowed. If not 18, then according to the else condition, you can just say output not allowed. And then every time you start an if statement, you need to put an end if at that. It's similar to saying that every time I start a sentence, like my name is Mars, and it's my English paper, we always put that what do we call it, full stop at the end, right? We always put this full stop at the end. This full stop, when we are making use of an if statement, is basically end if. So it's really important you put up this end if. Another one common question which a lot of my students were asking when we were doing those past papers were that, sir, if I have a condition like this, if age is less than 18, then output not allowed. What if I say, or like allowed, what if I say that I don't need a different condition? Like I don't need this else part. If I don't want this part, is it possible I just put an end if up here? If I do something like this, is it correct or not? Yes, it is. So it's not necessary that you always put this else statement. Okay. So if you are in a scenario where there is no requirement for the else and you just want to check the condition once, that if age is less than 18, you just say output allowed. If not, do nothing. Just end the program, end this condition up here. Then you can skip this else part. It's not compulsory. So it's important that you are aware that this part is not compulsory. A lot of my students were asking this. So if you had a similar query, don't worry at all. Everything will be inshallah good to go. So this is one other example that I'm short of telling that every time you're writing code in pseudocode, there is one thing known as indentation. What's indentation? Indentation basically refers to this concept of whatever is happening, you basically leave a bit of gap with every next action. For instance, this condition of then output, this basically happens when this if statement becomes true, right? So this thing basically depends upon this if. So anything which basically depends upon the previous action of whatever was happening, we write that with a bit of gap. You see, we've created this gap. And this gap is what we call as an indentation. Now, the purpose of this indentation is to basically make the code more understandable and more structured. And if you, let's say, do not indent your code, you won't be losing the marks in the first 60 marks if you have a question. But do know that in the 15 marker, you have marks for indentation. So it's really important that you practice indentation as much as possible. If you don't understand it, no worries. Try to do as much indentation. Don't be like that one person who sent me the code who was like literally if age is less than 18, then output allowed. Don't be like that one person, please. Please, your examiner will not be able to understand what's happening. And remember, the reason, let me tell you, you would have heard this one thing that you can recheck your papers. You can recheck your papers. Your examiner goes through a long set of training. It's very unlikely that you get a wrong grade. But if you do get a wrong grade, it's in most cases because your examiner did not understand what you were trying to do. So do ensure that whatever code you're writing, it's as clear and understandable as possible. If at any point you feel like the code is not understandable, you can always add a comment. A comment is added by 2 slashes and then you can explain what you're trying to do. So if there is a question, even if it's not a 15 marker, but you feel like I want to explain the code to the examiner so that he understands what I'm trying to do, you can basically explain it by adding a comment. And that's 100% allowed. Perfect. That is one way of basically implementing a conditional statement using the if, then, else, and if. But this if then else and if works in a way where if I, let's say, have one condition, if condition 1 is true, then you do one thing. If not, then we say else, you do the other thing. But what if I'm like, okay, if grade is equal to A star, I'm going to be like, okay, if I guess I wrote it even up here. So yeah, if grade is greater than 80, output excellent. Else, if I have another condition within the else statement, let's say else if grade is greater than 70, output great. Else, you might say work hard. So if I have a condition where within the else statement, I want to implement another if statement, how will I do that? For that, we have this if, then, else, if, and if statement, where you don't have to memorize this, by the way, but it's just to let you know that we have implemented the same if and else statement, but within the else statement, we basically brought in the if statement again. Another common question I know a lot of you would have in your mind, sir, we generally write it this way, else if. This is wrong. There is no such thing as else if, according to your syllabus. According to your syllabus, it's basically else, and then in the next line, you write the if statement. So else if grade is greater than 70. So please don't be like else if joined together. Even if you want to write it in one line, do leave some gap in between to indicate that if is separately done within the else statement. And this concept of when we have an if statement within an else statement, and that else statement is within an if statement, is known as nested if. Why? Because we say that if this thing is true, then do this. If not, if this thing is true, then do that. If not, if that thing is true, then do that, else do this. So if we have consecutive if statements being used again and again, again and again, again and again, so in that case, what do we call it? In that case, the thing is, you will be making use of something known as nested ifs. So this concept which was implemented up here is known as nested ifs. Let's move on to now the next way of basically implementing multiple conditions. And that is that, for instance, I have to create multiple conditions like, okay, grade is greater than 70, output grade. Then if I have to add further condition, if grade is greater than 60, output okay, then else if grade is greater than 50, oh my bad, if grade is greater than 50, then do that. Then if else if grade is greater than 40, then do that, and so on. If I have multiple else if statements, you can sort of identify that it makes it really difficult, right? It's very challenging. It sort of makes it very out of the box. I'm unable to understand what's happening because I have to write if else, if else, if else, if else, and it makes it very challenging. So to prevent this, what the examiners and what the programmers did was they came up with a newer method, which was known as the case of otherwise end case model. This is something which you only need to use when you have multiple cases. So if you have one, two, or three cases, it's better to go with if statement. If you have more than three cases, or like four or five, you should always go with the case statement. And how the case statement works is that you take some value, okay? For instance, I input some grade. So this grade is being inputted by some user, right? So I have a value which is being stored in this grade variable. It could be anything. It's some value inside it, right? It could be A, it could be B, it could be C, it could be D, it could be E, right? So now what I'm going to do is I'm going to be writing this condition. I would be like, okay, you do case of the variable grade. And then I say that if in the variable grade there is value A, then you do this part. So I say that if the variable grade has value A inside it, you output excellent. If the value in grade is B, you output good. If the value in grade is C, you output okay. If it's D, you output needs work. If it's not, then this means definitely it has to be maybe an F. So you just output otherwise, output failed. So what's generally happening up here is that we are basically saying that if there are multiple grades and all those grades are basically corresponding to some value, whatever the value is, based upon that, you need to do the condition which is being stated up here. And the general formula for this is that if condition, this is exactly the same thing as writing the if statement, but rather than having something in terms of else if, what we are doing is we're making use of case statement. So we're like case of a variable. If this is the value within that, or I can say condition number one, if that's the value in the variable, you execute this statement. If this is the value, then you do this. If this is the value, you do this. If otherwise, if none of these values are within, then you go with the otherwise. Like for instance, none of the value, if this is A, B, C, but this had E. E is none of them. So you go to the otherwise part, you do the statement. And of course, just the way we write the end if, I forgot the end if up here. Let me write the end if. Just the way we put an end if, we up here also need to put an end case. And this end case will be used for the case to indicate that this has basically ended up here. Now, generally, this case of statement is being used when you have to create a menu in a 15 marker. How? Because in menu, you have like 4 or 5 options, right? Maybe if I, let's say, have to play RDR2, Red Dead Redemption 2, and I launch the game, I'm on the menu page. I have settings, I have the story mode, I have, let's say, some other options, maybe select mission or whatsoever, right? So if I have multiple options, I cannot go with if statement. It's going to be very inefficient. So what I do is I go with the menu part, which is basically implementing the case of statement. But I'm like, okay, case of whatever the input of the user is. If it's menu, open this. If it's if it's story mode, open this. If it's setting, open this. If it's, let's say, change character, do this. If it's like score points, do this, and so on. So whenever you have multiple statements and you want to basically create a condition where you want to check each of them alongside a value, but you don't want to make use the if statement because it's inefficient, you go with the case of statement. And that is how you implement the two ways of conditional statements. So if ever in exam they call you and ask you for conditional statements, do know you can talk about this and you can also talk about this. Both of them are conditional statements. But if within them you were asked to do something, then what are the types? One is the if, then else, and if one, and the other is case of otherwise and case one. And that is how exactly you need to make use of your yeah. So for that reason, if you have any sort of, what do we call it, condition, you're going to ensure that you follow these two methods to have that condition being evaluated and solved. This marks the end of our one part of chapter number 7, which discusses your conditional statements. Okay, let's move on now. For all the questions, I know you guys are raising the hands, but we won't be able to accommodate them because we're a bit short on time too. I might be skipping my own class, by the way, guys. I have a class at 5, but I feel like I will be skipping that for you guys. Kya yaad rakhoge? But do ensure that you take help from the class. And for anybody who is not in the community group, I'm writing my number up here. Okay, perhaps I'm going to write my Instagram page. So you just reach out to my Instagram page at the rate code catalyst underscore. We share a lot of useful stuff up there, and I'm gonna create a new group. And in that group, you guys can join in because the community were free. I'm gonna create a new group. You can join in that group, and in that group, you can basically access all my resources. And of course, when I get free, I respond to student queries too. So please, if there are any questions, ask them in the group, and I would love to answer them. But please don't be like literally DMing me, because even though if you do DM, perfectly fine, but I'm very bad in responding to DMs. I'm very bad, like literally. So yeah, so I hope all of this is clear. Now let's move on to the condition that what if I say that one of you, let me take someone's name. So let's say I have Hamad in the class, right? So if I take Hamad and Hamad, let's say, gets a B grade in his quiz, and Hamad is a distinction level student. Okay, I trust Hamad to get a top in the world distinction in computer science, inshallah. But he's like, okay, I got a B. And now Hamad is like very sad. He wants to like, okay, say that I want to tell sir that, sorry, sir, I'm gonna work hard. And then he goes on to write, sorry, sir, I will work hard 100 times. So tell me, isn't that very challenging writing the same statement again and again, again and again, again and again, again and again? So what Heather Ali does is, because he's his friend, Heather Ali is like, bro, chill. You're a CS student. Just write a code with just all of this automatically. And then Ahmad is like, okay, I don't know this. What do I do? So Heather then introduces him to the concepts of loop or iteration, which is basically the concept in computer science where if I want to repeat a set of code, how do I repeat that? So for that, there are three possible ways. So for instance, if Moise wants to output the statement that I will get an A star, inshallah, 100 times, one way is that I do write the statement one by one, one by one, one by one, up to 100 times. That's very, very, very time wasting. The other way is that I make use of one of the three methods. One of the three methods. The first method is known as the for to next loop. In this, what I do is I'm like, okay, for a specific variable, like every time I'm basically counting or like I'm doing something, I keep a count, right? Okay, if I'm like, if I tell one of you to pick up all the stuff which you can see on the ground at this point, and once you touch 50, you need to stop. So what are you going to do? Every time you pick something, you're going to count once, twice, thrice, 4 times, 5 times, 6 times, 7 times, until you do it for the 50th time and you're like, okay, I've met the condition, now I can chill and rest and play Fortnite. Okay, so when you're writing the code, it's also pretty much similar. You need to make use of the for statement, where what happens is that we say that, okay, for a specific variable, this is a variable which could have any value, any name, any value. Okay, for a variable which is, let's say, count, which is basically counting how many times something is happening, you need to start with its value being 1 until the value of count does not become 100. You need to keep on outputting, I will get an A star inshallah. And then every time you output this once, you need to go to next count, which basically means that into this count variable, I'm going to add 1. So when I start the program, count value will be set to 1. This entire code for to next will ensure that it runs until the count value is equal to 100. But then I'm going to output the statement, and after outputting the statement, I'm going to say next count. So this next function in the for loop is basically something which increases the value by once. So this count will then become 2. Then it's going to become 3, and so on. It's going to become 99. And finally, the moment it becomes 100, because the maximum limit is of 102, this is the starting limit, I have reached my end goal, and my count variable also has the 100 value. Then I would be like, okay, I'm done. And I stopped. So this is how, if I want to repeat this statement of output, I will get an A star inshallah 100 times. I'm going to be implementing this for loop. I would be like, okay, for the count variable with its value starting from 1 all the way to 100, the output, I will get an A star. And every time you do it, you do next count. So you move on to the next one. And this code basically repeats it 100 times. Why? Because I'm starting from 1 and I'm making sure that this statement is outputted 100 times. Perfect. Then, of course, sometimes a lot of the students out there will also have this one question that, sir, what if I started with 0? If I'm like, okay, you need to go from 0. So if you start this loop from 0, then do know that for the first item you pick up, so like for instance, if I have these two pens in front of me, now normally what we do is we're like, okay, this is pen number 1, this is pen number 2. But if I start, because my computer counts 0 to be a value, okay, computer counts this 0 to be a value. So if I want to count it as a value, do keep this in your mind that it's basically going to be done in a way where I would be like, okay, this is my 0th pen, 0 pen. This is my first pen. And then afterwards, the second one will be my second pen. So if you start off your count from 0, however, I would recommend always start from 1 to 100. Starting it from 0 gives you no benefit at all. Always go with 1 to 100. That's the best way out there. But if let's say anybody starts off with 0, then know that you're going to go from 0 to 1 less than the maximum. Why? For instance, I'm trying to count 5 elements. So one way is I count from 1 to 5, right? 1, 2, 3, 4, 5. But what if I'm like, okay, no, I want to count from 0 to 5. So then it's going to be 0, 1, 2, 3, 4. So when I count till 4, which is 1 less than the maximum value, I've counted 5 values. So similarly, if I want to count for 100 items, but I start with the value 0, I'm then going to go with 1 less than the maximum one, which makes it what? It makes it a 99. So for count 0 to 99, if I do the same thing, it's also going to repeat it 100 times and output the statement just the way it is. Perfect. So these are a few other examples too. So if I have to output a few numbers, like a variable which has numbers, if I want to output this value, like, okay, whatever the value is inside this, you need to output it. So because this is a variable, when I do for 1 to 50, this means that you take the one value, you put it in this variable numbers. So if I now do output numbers, number has the value 1, so it outputs 1. Then you do next number. Next number basically increases the value of numbers by 1. It makes it 2. Then you again do output numbers. So the value of numbers is basically 2, and this makes it basically 2 up here. So now you're basically outputting the value 2. Then you again do the next numbers. So it then becomes a 3. Then you output that value, it becomes a 3. And it so on moves up till you reach the ending criteria, which is a 50 up here. So you go to the 50th point, you output the 50th number, and then you're like, okay, I've met the condition. Why? Because this is my starting point, and this 50 is my ending point. The moment I reach my ending point, I have to stop. And then I stop, and when I stop, I have to basically, I'm done with my work. So the general syntax for a for loop is that you write the name of a variable, then you indicate that this variable should start from this point and it should go till this ending point. And in this, you should do all this code. So when I talk about statement, this means that you're executing some code. And once you're done with executing it once, you'll be like, okay, next variable. So you do the same thing, but with the value of this variable increased by once. And you keep on doing it till the value of this variable is basically equal to the end value or greater than the end value. Clear? That is how you use a for loop. Now, a lot of students, I know you would be aware of for loops, but you have this one question, sir, I don't understand when to use for loop, when to use the other loops. So you're going to also answer that, inshallah, when we are done with discussion of all the loops. So if I have discussed the for loops, the second one is if I have to make use of repeat until. What's a repeat until? So up here, I'm specifying that I need to output it how many times? I need to output it 50 times. So I need to all the way start from 1 all the way to 50, outputting the number. But for instance, if I want to make use of a model where I'm not sure how many times I have to output it, for instance, I'm like a repeat, not like repeat, let's say you keep on inputting until number -1 is input. So you need to keep on repeating the thing until -1 has been inputted. So for instance, if a person does not enter -1 for like 100,000 billion times, then the program will keep on running. But let's say he enters -1 at the first time, the program is going to end. So when a scenario like this comes up where I'm not sure how many times I need to repeat, we go with the repeat until or the third type of loop, which we're going to discuss after this. What a repeat until does is, it is that type of loop where the number of iteration is not known. And it repeats till a specific condition is being met once. Okay, so it keeps on repeating until a specific condition is being met once. And such a loop is told to be that it has this feature that it runs at least once. Remember this point for your exam. This is an important point. They generally ask this in MCQs. Repeat until is the loop which runs at least once. Why and how? We're going to see that right now. So what happens in this is that for a for loop, we have a variable which automatically increases a value. But in the repeat loop, we don't have something like this. In repeat loop, we are like, okay, you repeat doing everything which is within this until some condition becomes true. So you need to keep on repeating something until a condition becomes true. So for instance, we had a count variable previously, right? We were like, okay, for count with the value starting from 1 to 10, we changed this model and we are like, okay, now there is a count variable which has the values 1 at the start. And I'm like, okay, you need to keep on repeating until the value of count is basically greater than 10. So until the value of count is not greater than 10, or I say until this condition is basically false, you need to keep on repeating it. So until this condition is false, you keep on doing whatever is inside. But in the for loop, we had a good scene that it was automatically increasing the value of the variable. And they repeat until you don't have this part where it automatically increase the value by once. So what we on our own manually do is that we every time increase the value by 1 by making use of a counter. We increase that counter value by 1. And that basically ensures that if it was originally 1, you output it once, you output high, then you change the value, 1 becomes 2. Then is 2 greater than 10? Nah, this means false. So you go back. You do it again, you keep on doing it, it becomes 3, 4, 5, all the way to 10. And then the last time it becomes like you do it the 10th time, you do it the 10th time and output high. So output has been outputted for the 10th time. And then 10 plus 1 becomes an 11. So 11 is stored up. Is 11 greater than 10? Yes, it is. This becomes true and you exit the loop. So the condition sort of works in a way that you have a repeat, then you basically statements and you go until a condition is being met. And you keep on repeating until this condition becomes true. If it becomes true, you exit the loop. If it's not true, if it's false, you go back and you repeat everything again. Okay. So if I have to give you guys a condition like, okay, for instance, I want you to output only even numbers. Only even numbers. You start from 0 and then you output even numbers. Because I know even numbers are all the way after every 2. So like 2, then you add 2, then 2, then 2, and so on. One way is that I'm going to be like repeating it until the number is greater than 10. And every time I'll be like, okay, output the number. And then in the number, you add the value number plus 2. So originally number was 0. You're like, okay, 0 has been outputted. Then you do 0 plus 2, which makes it 2. 2 is being stored up here. Then is 2 greater than 10? Nah, you go back. You output this 2. Then you again increase it by 2. And so on, you go on until this condition becomes true. When it becomes something like when you output it for the last time, let's say now my number is 10. The output number, which is 10, so you have 10 up here. Then you do 10 plus 2 in the next line. It checks, becomes 12. 12 is greater than 10. Boom, done. This becomes true. So you exit the loop. So one point here to note is that this checks the condition at the end. It checks the condition at the end. That's the reason why we said that it's going to run at least once. Let's say I set the number value to be something like 12. This means that if the question was to only output the values between 0 and 10, if this was the question, if my number value is 12, and I go into this repeat loop, it's going to output the number first. So it's going to output 12 and then it's going to make it 14 and then it's going to check the condition, right? So my condition is being checked at the end, which means that right now, definitely my condition is greater. So it's going to exit. But before exiting it, this ran once. And that's the reason why we say that repeat until loop is the one which runs at least once. At least one. It has to run. Okay. Another point here to notice that whenever you make use of repeat loop, people make this one mistake that this variable which they increase, they put this variable like this num0 inside the repeat statement. So like in this case, they did count and you assigned it the value 0, but you did it within the repeat loop. That's wrong. Why? Because then it's going to run infinitely times. How? Because I might be like, okay, count is 0. You output the value 0. You increase the value by 1. It becomes 1. And then you do until count is greater than 5. Because it's not greater than 5. Until this count is greater than 5, because this is not greater than 5, you go back, but now this count again becomes 0. So rather than it increasing from 1 to 2, you set it to 0 again, so it again becomes a 0. Then it becomes a 1, but then it again becomes a 0. So the problem is that you're sort of setting the value to 0 on your own. For that reason, whenever you're making use of repeat loop, or the next one which you're going to study, which is the while loop, you always set the variable outside the loop. So your count has to be up here rather than inside the loop. This is also something which a lot of students generally mess up. And I would recommend everybody to be super duper clear with this. If you make this mistake, then it's going to cost you marks, which you shouldn't be losing at all. Perfect. Move on. So this was just a practice session for my students. So I will not be going through it. By the way, the notes will be available, so you guys can just go through them. I just sort of did some examples that if I, let's say, want to take input from user until they enter the number equals to 3, how do you do that? So you keep on repeating it. You say output enter the number. You can input the number until when? Until the number is equal to 3. And then I can, let's say, store the value somewhere like maybe x equals to 2 plus 3, and then I can output the answer. So this was just an extra step, but this is the main concept of if I, let's say, want to do something again and again until the number 3 has been entered. This is how you do it. So the concepts which we just studied, these are the questions for those. If anybody wants to have a look at those later on, you can. The notes will be available, but I don't want to waste the time on this. Let's get back to the class content because we don't have a lot of time and we have a lot of content. So I'm going to try as much as possible to cover today. If not, we might have to schedule another class maybe some other day, but I won't be free over the weekend, and also I might not be free in the next week. Let's see what happens, but I hope it's going good till this point, right? So let me just drink some water. मेरा गला खुश्क हो गया, मर रहा हूँ, but then we will continue with VME breath. Crazy. All right, let's get back to the class content. So the third type of loop in our syllabus is basically known as the while, do, and while. What's the while, do, and while loop? So this one is pretty much very similar to the repeat until loop which we had previously. But the repeat until loop had the condition at the end, right? We saw that the condition was being checked at the very last point. So it was like repeat, and then at the end you were like, okay, repeat. And at the end you were checking the condition until something happens. But while loop is that what if I want to check the condition at the top? So like while some specific condition becomes true, then you do some statements. So if there is a case where I want to check the condition first, like when I say while my password is equal to 123, let's say my password is 123, and I say while my password is equal to 123, only in that case output bank, what do we call it, deposit. So whatever the bank deposit amount is. Okay, if it's not, then you don't. So if I have to check the condition at the top, for that we have a loop with the name of while, do, and while, in which you have like, let's say the condition checked at the top, and then you do the part and end it with the end while. For example, an example is, let's say I input an age and I say while this age is less than or equal to 18, you do what? You say output, you are still a child. And then you increase the age by once. And now when I increase the age by once, you keep on adding it up and it goes back. And now if your new age, let's say age was something like 12. So 12 plus 1 is 13. Again, you go back. Is 13 less than equal to 18? Yes, it is. Then you do this. Again, you do this. Again, you do this till the point that this condition becomes false. So a difference between repeat and while loop is that in repeat loop, you said that it's going to repeat until this last condition at the end. This condition becomes false. Whereas in this is basically going to run until this condition is basically true. The moment this becomes false, you're going to stop. And in the while loop, we said that when the condition became true, you're going to exit the loop. So this is a small difference which should be clear. If not, then it can be very problematic. But the problem, one other important point is, which can come up in terms of theoretical question, this while loop, because it checks the conditions at the start, we call such a loop as preconditional. So in this structure, the moment the condition becomes false, you exit the loop. And the loop does not even run at once. So for instance, I say that if the age inputted up here was something like 25. So because the condition was being checked at the top, while 25 is less than 18, is it? No, right? This condition is false. So because it's false, this loop never runs. Never runs. Whereas if it was a repeat loop, in repeat loop, the condition was being checked at the end. So because the condition was checked at the end, 25 would have outputted you are still a child. And then at up here at this position, you would have exited. But that's a problem. We don't want this. Let's say we want a scenario where it even does not output it at that point. So for that reason, we make use of repeat preconditional loop, which is why my while loop. So a few examples for while loop will be that if let's say I want to print the star symbol 5 times, how do I do that? I'm going to, just like before for the repeat loop, I'm going to create a counter and I would be like, okay, while this counter, generally we give this a name of counter because it's counting, right? How many times something has happened. So I say that while this variable counter has a value less than or equal to 5, while it has a value less than or equal to 5, you keep on doing this. So because my counter has the value 1, 1 is less than or equal to 5, you output star, then you increase the value by once. If you don't do this, it's always going to keep on outputting it. So I output this star once, then I increase the value. This becomes 2. 2 is less than 5. Yes. You again output it. Then this becomes 3. 3 is less than 5. Of course. 4 is less than 5. 5 is less than 5. And the moment this becomes 6, is 6 less than or equal to 5? No, it's not. So this becomes false. Because this becomes false, you exit the loop. And that's the whole method used whenever you want to make use of a while loop. Now, the important exam tip for you all: when do you make use of while loop, when to make use of repeat loop, and when to make use of for loop. So whenever you are not sure that how many times I need to repeat a set code of action, I'm always going to be making use of either the repeat loop or the while loop. So if you know, there are two ways, okay? Number of repeats not known. So if you're not sure how many times you need to repeat, you either go with repeat or you go with while. If you have to check the condition at top, you go with while loop. If you can check the condition at the end, you go with repeat until. Okay. But if you know how many times I want to repeat, I know I want to repeat, let's say 10 times. When I'm fully confirmed sure that I want to repeat something for a specific number of iteration, I go with for loop. So that's the reason while loop is known as preconditional loop, because it checks the condition at the top. My, what do we call it? Repeat until is basically my post conditional loop, because it checks the condition at the end, post conditional loop. Whereas my for loop is count control loop. This is my count control loop. Why do I say count control loop? Because it knows the exact count to which it needs to repeat this. So I know the count for which it needs to repeat it. I know it has to repeat 100 times, but for the other two, I don't know. So if ever in exam a question comes like this, you should see, if I know how many times it's repeating, go with for loop. If I don't know, I need to check the condition at top, go with while loop. If I can accommodate the condition being checked at the end, sometimes there are cases where you have to check the condition at end, you go with the repeat until. And this basically marks the end of our 50% course content from chapter number 7, where you have sort of covered up loops, and we have sort of covered up conditional statements and the basic introduction. Right now, we are going to be jumping into one of the most complex and important part of chapter number 7, which is basically the standard methods of solution. When we talk about standard methods of solution, these are basically a few programs which the examiner beforehand told us that, guys, before coming to exam, do ensure that you are fully confident with these few methods of solving a problem. So your examiner told you that you should be familiar with all this. And so we're going to learn how to make use of that stuff in our code. So the first standard method of solution in our syllabus is known as totaling. For instance, I want to add or a few numbers, find a total, find the sum of a few numbers. How do I do that? So the way of finding a total is that the equation basically goes in a way that if I have, let's say, a variable total, the total originally has the value 0. Then let's say in the total, I add the value 5. So my total was 0, then 0 plus 5 makes it 5. Then this basically comes out to be 5. Now, if I want to add plus 3 inside it, so how will I do it? So for that, I need to do it total plus 3. Why? Because this total originally stores the value 5. So 5 plus 3 is going to be my new answer. But where will I be storing the new answer? Again in the total variable. So I'm going to go back. I'm going to store the answer again back in the total variable. This concept of where you do total being assigned with the value of total plus some new value, that is known as totaling. So I can even write it up here. Total being assigned with total plus value. That is what we call as totaling. So I gave this one example to my students that, for instance, I'm sort of adding the total marks for all the 30 students in my class. I made a for loop which runs from, which is counting, the student count is a variable which counts how many students we have. It starts from 1 all the way to 30 students. And for every student, it's like, okay, output, enter marks for student number. And then you do comma student count. What does this mean? This means that you're saying enter marks for student number, comma, and then you output this value for 1. So this would be like enter marks for student number 1. Then enter marks for student number 2. This comma basically is a divider between this quotation marks and this variable. So when you want to add multiple things under the same output statement, you differentiate or divide them using a comma. Okay, you don't add a plus like this. That's only when you want to join two strings. If you want to separate them, make use of a comma. Then I input the marks and I basically add these marks in the total variable just the way I shared. So I did like that in total variable, whatever the previous value of total is, add the marks into that. So if this was 0, 0 plus let's say 20, this becomes 20. Then next count you go for the second student let's say scored 70. So then you do 20 from the previous one plus the 70 of the newer one. Makes it 90 and then you store this 90 in total. Then you do it again. Then this is 90, 90 plus 30 makes it 120 and you store that up here. And so on it goes on. And at the end, your total is this total variable. So this totaling is the concept of adding the numbers consecutively. And if I have to make use of the same logic using a while loop, I'm going to be basically setting up a total variable just like before. Then I'm going to, because there wouldn't be an automatic counter which goes, I'm going to set a separate counter like student count with 1. And I'm going to make use of the condition like while this student count is less than or equal to 30, while this condition is true, do this. Take the marks, add the marks into total one, increase the student count by once, and boom, at the end, you'll be like, output the total. That's one of the 7 standard method of solutions in your syllabus. Just like that, you move on to the next one, which is basically counting. What is counting? Counting is the concept where you basically are generally just counting how many times have a specific thing happened. So if I, for instance, want to count how many times have a specific action taken place, or how many times a specific thing happened, how do I do that? That will be basically done by making use of the counting variable. How? I'll be like, okay, easy scene. If I want to count that how many pens I have, so if the counting variable x, or like the number of students who have passed, are originally 0, if pass count is originally 0, let's say in the class there are 0 students who have passed. If one student passes the exam, I want to increase this by 1. So if I want to increase the value by 1, the way I need to write this in pseudocode is this. I'll be like, okay, whatever the previous number of pass students were, if they were 0, add 1 into it. Whatever the new answer is, store that in the pass count variable. Then likewise, whatever the students who have failed was, you add a new value into that 0 plus 1 and you store that inside it. So similar to that, but previously we were adding the number so that it was finding the total. Right now we are just increasing the value by once. So every time you increase the value by once, it's basically that we are counting it. And if I have to give you an example for it, let's say we might want to write a pseudocode program that checks how many students have passed and failed in a class of 30 students, given that the passing marks are 60 out of 100. I might do something like this. I'd be like, okay, the students who have passed are 0, the students who have failed are 0. Then I'm going to make use of a for loop, and I'll be like, okay, let this for loop run all the way from 1 to the 30th students. And for every student, I'm going to take the marks input, and I'm going to check using a conditional statement that if the marks are greater than or equal to 60, this means that the person has passed. So I'm going to increase the pass count by 1. So you see, I would like, whatever the previous student, how many, I'm not sure how many people have passed. Let's say for the 20th student, till the 20th student turn, let's say 10 students have passed. So in the 10th one, increase that by 1. So make this 11 and store this 11 in the pass count variable. And let's say if the student marks are not greater than 60, this means he failed. So in the else condition, you increase the fail count and then you do end if. And you did this for one student, I need to do it for the 30th one. So if this had the value 1 now, I need to make it 2. So I put this next counter. And at the end, I'm just outputting that the number of students who passed the exams are this, and the number of students who failed the exams are this. So that is how you basically make use of counting as well as the concept of basically क्या कहते हैं total. Is this clear, everybody? So I was thinking that we can have a small break. Okay, we have covered like around about 1 hour 20 minutes content. Let's have a small break of just 10 minutes, not more than that. We will be back at 4:50 inshallah. And then we can continue with the remaining part. We can have like maybe a small further part. So break till 4:50. Okay, and then afterwards you can rejoin in, or if you want to stay in the class, because we have a limit. If the limit exceeds, then you won't be able to join in. So break till 4:50, and inshallah we're going to come back at 4:50 to further continue, and let's see how long can we go till. But generally we're gonna go till 5:30 or maybe 6, inshallah. But yeah, we have a break till 4:50, and we're gonna try our best to cover up as much as possible. Okay, so your break starts now, and see you guys inshallah at 4:50. The class is open. You guys should not leave. If you want to leave, up to you. But yeah, you don't want to leave it. So sir, Asr Nimaz is at 4:48. Okay, so just a minute. You guys can go just Chalo, bas, okay, you have break till 4:50. At 4:50, you guys can return. All right, everybody, we are back. So let's just wait for a few minutes if anybody else might want to join in, and we can start off at 5 then. Even like before, just give me a minute. Let's start off then, guys. Let me just send a message. I hope you guys are here. Can you just send a thumbs up reaction? You guys can. I'm not sure though if you can or not, but yeah, join in. Perfect, perfect. Thank you so much. And the other group too. Perfect. Thank you so much, Sanan and Aisha. All right, then let's start off once again. Bismillah ar-Rahman ar-Rahim. So let's continue from where we left. So the last discussion we were sort of having was over the standard methods of solutions. So we're going to continue from where we left. Right now, we will be jumping into the third standard method of solution, which is sort of regarding how do I calculate average. So this is a very commonly being tested question, whether it's the 15 marker, whether it's those normal pseudocode question, they always ask you to calculate average. And you should be knowing the mathematical formula for calculating average. If you don't know, don't worry. So to calculate average, you need to find the sum of all values, which basically means you need to find the total, and then you need to divide it by the number of values. So for instance, if I say I want to find the average of 5 students, the average marks of 5 students, I'm going to add the marks of the 5 students, and then I'm going to divide it with how many students marks did I add? I added it of 5 students, right? So I'm going to be, let's say the total is something like 250. I'm going to divide that with 5 because we have 5 students, and this is going to give me the average of, let's say, 50. Okay, so that's how you mathematically find out average. In your exams, I sort of created this one example question for you, that if, let's say, Sarmaz conducts a grand paper 2 assignment to see how well the goated students perform before the final CIEs, write a program to calculate the average of the class, and let's say the class size is of 35. How do I do that? So for that, the main step which everybody needs to follow is that you first of all calculate the total marks for the entire class, and then you divide the total with the number of students to get the average. So for instance, for me, it has to be the total divided by 35. Why 35? Because I know that there are 35 students in the class. So if I have to use this equation to find the average, how do I implement this model in terms of pseudocode? Now, because I have a few variables, I always have to initialize them. These setting values to 0 at the top is always referred to as initializing. And this is very, very important. One important point to note is that in your paper number 2, you are not required to declare everywhere. Okay. If a question asks, only then you are required to declare it. Only when the question asks you to declare it. If it does not ask you to declare it and you declare it, it has no benefit to you, right? It won't get you some extra marks. But really important is that you are not required to declare, but this does not mean you aren't required to initialize it. You're always required to initialize the values no matter what happens. So whenever you're writing the program, whatever values you're going to be taking use of, initialize them at the top. So for instance, total being with the value of 0, average being with the value of 0. Some students have the question, sir, why didn't you set student number to 0? So this for loop, when you do this student number 1 to 30, you see this arrow, right? It's assigning this 1 into this. So the initializing for student number 1, student number has been basically done within the for loop. So it has also been initialized, but it has been initialized within the for loop. So what I just did was I created 2 variables, total and average. Then I went through the entire class from the first student all the way to the 35th student, and I asked them to enter the marks. For every student, I entered the marks and I calculated the total just the way we saw, right? I did total, and in total, I stored total plus the marks. And likewise, once I did that, I did go to the next student. So I did for student number 1, 2, 3, all the way to 35 students. And every time my total were being added up. At the end, I have something like 2,760 as my total. But I need to find the average. So I now need to divide this with the number of students. So what I did was that I had an average variable. In that, I wanted to store the value of whatever the total marks were divided by the number of students, which is 35. And when you do this, the answer which you're going to get from this, that's my average. And that is being stored up here in the average variable. Now, if I want to output it, I'm just going to write output, the average score of the class is average. One another point is that you can see that up here before inputting, I'm always outputting stuff, right? Output, please enter student marks. Output, the average score of the class is this. In your paper, if they expect you to have these messages, if they expect you to write these statements, there will be a term known as meaningful messages in the questions. If the question included the word meaningful messages, my bad, messages, do know that before every output input, you need to put these statements. You need to tell what's happening. If the question does not ask for meaningful messages, even if you ignore this statement and you're directly like input marks or you directly do output average, that's 100% fine. So it's really important to understand that at some points you are required to output these sentences alongside the value. Where are you required? When the question clearly mentions that you need to include meaningful messages. And how do you output a statement with a text and a variable? You write the text first, and then you add a comma, and then you write the variable name. This comma, just like I stated before, differentiates it. One other important point is that whenever I output something, if it's a sentence, I do it always within double quotation mark. This is a really, really important point. I know a lot of you would have never knew this. You always use double quotation marks when you have a string. But if I have something like a character, I use a single quotation. What's a character? A character is a single letter. Let's say I only want to store M. If I only want to store one letter, I use a character. We're going to study this in chapter 8, inshallah. But for a character, you're going to use a single quotation marks. But whenever we have a string or like a longer text form, we always make use of double quotation marks. So if I have something like hello, I'm going to put it in double quotation marks. If I did something like this, I'm going to lose marks. Do know this will mean losing marks. In my A level CS paper number 3, I made this blunder. My code was correct though, but rather than using double quotation marks, I used a single quotation marks. And guess what? I lost marks. So I don't want you guys to make the same mistake, right? So ensure that whenever you're making use of a string, do include these quotation marks, and that too double quotation marks, right? So perfect. That's how you calculate the average. Now we're going to come to that very common question where a lot of people have a lot of challenges, a lot of questions and all that stuff. When the question asks you to calculate the maximum of something. So if I want to calculate the maximum, this means that there will be a variable which will store the maximum value out there. So before writing the program of it, you need to understand one concept, that this maximum variable has to be initialized with the smallest possible value. Like people say that, okay, maximum needs to be the greatest one, right? So why do you set it to be with the smallest one? Like whenever you are making use of maximum, you always initialize maximum with the smallest possible value. The reason behind that is that whatever the value which you input up here is, you need to compare that value with the smallest value to see if that value is greater than the least possible value, you make that the maximum. Like for instance, if originally max is 0, this program basically works in a way that for student number 1 to 30, for 30 students, it asks for marks and it checks that if the marks are basically greater than the maximum marks, you make the maximum variable store the marks. And then you do it for the next student, right? We can clearly see that if let's say someone enters 45, I'm going to check that if 45 is greater than maximum, which might be like 20. Yes, it is. So then in the maximum one, you need to store the 45 from marks. So now my max variable stores the value 45. But for this to work efficiently, I need to set the max variable with something like 0 at the start. And you know why? The reason behind why we need to do this is that if I take this model up here, this class will, by the way, go all the way till 6 p.m. inshallah. Okay, so around about 6 p.m. So the reason why this will be set with 0 at the start is that whatever the user inputs, if let's say one student inputs the score 45, then at this point, if I say that if I ask you guys to calculate the maximum and one student says, okay, I scored 45. So currently, given that only one student gave the score, isn't 45 the highest in the class? It is, right? So we need to set maximum in a way where I'm going to check that if this 45 is greater than the maximum, then you make the maximum variable store the value 45. And this could be only done with maximum is something smaller than 45. Now, if I set maximum to be something like 100, which a lot of people might have in their brain, that why not set it 100? Now you tell me, is 45 less than 100? No, it's not. So this means your maximum variable will stay the same as 100. But in reality, because we only inputted one value, my at this point class highest is 45. So maximum should have 45. So for that reason, we initialize maximum with the smallest value, so that if it is something like 45 is greater than the smallest ever value, we change it this way, where maximum is now having the value 45. Perfect. Then you do it for the next student. Let's say student number 2 scored 70. Then you compare that 70. If 70 is greater than 45, you make the swap. So maximum now stores 75 value. Then for the third one, let's say the third student scores 5. Then you compare. Is 5 greater than 75? No, it's not. So you don't do anything. You just move to the next student. So you see the maximum value stays the same. Then the next one did 98. So is 98 greater than 75? Yes, sir, it is, because it is. You make maximum as 98. And finally, someone enters 29. Is 29 greater than 98? No, it's not. So nothing happens. Maximum stays the same. But the main point here to understand is that this all happens perfectly because we have the maximum initialized as the smallest value. Now, the shortcut up here is that whenever the question asks you to calculate the maximum variable, the variable which will be having the maximum value will be initialized with the smallest possible value, which in most cases is a 0. But it's not necessarily 0. It is the smallest possible value. So if I have to calculate the maximum between 100 and 300, the smallest possible value is what? It's 100. So my maximum will be initialized with the value of 100 at the start. And then I'm going to make use of this code where I would be like, for every value which is being inputted, I'm going to check if that value which was being inputted, if it's greater than the maximum value, then in the maximum one, I want you to store that marks value. And if not, if the marks are not greater, then you just move on. You do nothing. You move to the next student. And then at the end, once it has run for all the 30 students, at the end, maximum will be having the highest value, like the way we saw up here, 99. So it's just going to output that the maximum marks in the class are 98. And that is how you basically make use of the maximum function. Now, the code for it is pretty simple. The major challenge which a lot of people face is that they don't understand this part of why max is initialized with 0, which I hope it's clear at this point. Just one shortcut: whenever you are asked for maximum, set it to 0. Because the minimum one is exactly opposite of this. When I have to calculate the minimum, we always initialize the variable minimum with the largest possible values. And why is that so? Because I'm going to, let's say, take an example of, for instance, I want to store the value, some values, right? So for instance, I have to find the minimum score of a class. So I set minimum to be something like 100. And then one student enters his marks like 97. So at this point in my class, what's the minimum score? Like, no one else has mentioned any score, right? So 97 is also the minimum. Okay, it might be the maximum score, but at the same time, it's also the minimum score, right? There is no score lower than 97 at this point. So I need to replace this with 97. So this becomes 97. Then if, let's say, someone scores like 65, so now my minimum should become 65. So I have to check, is 65 less than 97? Yes, it is. So you swap this becomes 65. Then I have to check if there is something like 72 now inputted. Now, is 72 less than 97? No, it's, is less than 65? No, it's not. So you do nothing. You do nothing. Minimum still says the same as 65. You do something like 52. Yes, 52 is less than 65. You replace that. But now, for all those who might have this one question in their mind, sir, how will this be different if I set it to be as 0 at the start? Let's say you set minimum to be 0. So now, if I do the condition, if 97 is less than 0, is this even true? No, right? So my minimum in that case will always stay as 0, which I don't want. So the shortcut for finding a minimum is that you always initialize it with the largest possible values. So for instance, if I have to find a program that calculates the minimum obtained marks in a class of 50 students, I will be first of all creating a variable min, which will be storing the value 100, which is basically the largest possible value. Largest possible way ki jagah it's value. Okay, so you should be aware that's a small difference between maximum and minimum. The code seems to be very similar though. It's the same thing. You output, you take input, you check that if this marks this time are less than min. Previously in the maximum one, we were checking that if the marks were greater than max, you change it to max. But if this point, if the marks are less than the minimum variable, then you change the min variable with the newer marks which are inputted up here. So the major two differences between maximum and minimum are that when you have a maximum function, remember this, max initialized with lowest value, lowest ever value. Min always initialized with highest possible value. Max includes the greater than function, minimum includes the less than function. That's the exact syntax, that's the exact model you should know to ace your exam. So I can even take a score. Oh, it just went off, but yeah, that was the whole thing. So that's how you can make an algorithm to calculate maximum and minimum. Now, in your exam, when they give you a question to calculate maximum and minimum, you literally have to just take this part and you need to just change it to match the scenario. So maybe the variable name might change up, maybe a few array names may change up, maybe something else might change up, but the general structure which is being followed, it's 100% identical to the one which you guys can see in front of you right now. The same thing just goes on. Every time you initialize it with something greater and then you compare it this way. And if it's lower, you swap it. If it's not, you are good to go. So that is how you basically calculate the maximum and also the minimum. Okay. Now we will be moving on to one other concept, which is basically known as validation. We basically have missed two of the what do you call it, standard methods of solution, which are bubble sort and linear search, but I personally want to teach that once you are all clear with arrays, which will be something we are going to do in chapter number 8. So I'm going to see if we can do chapter 8 today. It seems to be a bit difficult though, but if we were unable to conduct chapter 8 today, we can have a separate class for chapter 8 maybe some other day, inshallah. Okay, so don't worry, I will be covering chapter 7 and 8 as promised with you all, inshallah. But yeah, just ensure that whatever I'm teaching, it helps you and that you make the most out of it. Well, I just had a pizza before having the class, and I don't know, maybe the cheese was, it was a bit different. So I'm like very, 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 very thirsty for some reason. But yeah, finally, we are in that topic of validation in chapter number 7, which is a concept that what if okay, I know that I'm going to input values. I know those values are going to go through some process, and then there will be an output. But how do I ensure that this input which is coming in, it's according to what my program expects? Is it according to the data which I need? Is it according to what the program is created for? Is it according to what my program should accept? For that, in computer science, there is a concept known as validation, which refers to the automatic checking by a program to ensure that the data is reasonable and accepted. The statement reasonable and accepted basically means that the data which has been entered, it is according to what I wanted. For instance, I want that the email address size should be between 0 and 32. So now if someone enters an email of 120 letters, I should reject that. I don't accept that. So if my program cannot reject this, this means that it's not validating it. So this time or this scenario where you might have seen that sometimes they say that your password needs to be of 8 characters. 8 characters. You would have seen this, right? 8 characters. If your password is of 7 characters, they don't let you create an account. Why? Why? This automatic checking is because that they implemented something known as validation. Now, in your syllabus, there are multiple validation ways, and in exam, they will be basically giving you a scenario where this validation code which you are just studying, it's directly going to be just implemented. So to ensure that you understand it fully, you need to understand what each validation check is for and how it's used to ensure that you're fully clear with what's happening. The first validation check in our syllabus is known as the range check. What's a range check? It's that check which allows us to see whether a value is between an upper range and a lower range. So for instance, I might say that, okay, there needs to be a value between 0 and 100 only. So if there is a value like greater than 100, or if there is a value less than 0, I want to say that, okay, there is an error. Why? Because the data is invalid. So if I have to check a condition like this, if the value is within a specific range, I'm going to make use of range check because it checks the value between an upper range, which is this 100, and a lower range, which is this 0. So anything between this is basically counted as acceptable or accepted. So how do I implement this in code? So for that, for instance, if I want to, what do we call it? Input the marks, and I might want to check that if the marks are less than 0 or greater than 30, I want to output an error. How do I do this? For that, it's pretty easy. I would be like, okay, you repeat and you ask for the marks. Now, if the marks are less than 0 or the marks are greater than 30, this means what? This means that it's out of the range, right? It's out of the range. Then I would be like, okay, buddy, incorrect range, please re-enter. And because I made use of a condition like marks is great, repeat loop, I will set this condition that this thing needs to repeat until my marks value is greater than 0 and my marks value is less than or equal to 30. Which means that if my marks value is between 0 and 30, this means that my marks value is between the acceptable range. So I should be good to go. But if my marks value is not between the acceptable range and it's less than 0, or I say that it's greater than 30, which means that it's out of the range, in that case, I want you to output that, bro, you entered the incorrect range, and then you should go and re-input the marks again. So if I have to take you through the code, let's say someone entered something like 75. So if we input 75, is 75 less, if 75 less than 0? No, right? But I had an or statement. What does or mean? This or that. So if either of them becomes true, you execute what's up here. So is this true? No, this is not true. But is this true? 75 is greater than 30? Yes, it is. Because it is greater than 30, I would be like, okay, I output incorrect range. Please re-enter. That's displayed. And then at the end, it does not end because it says until marks is greater than equal to 75 and marks is less than or equal to 30. So is 75 greater than or equal to 0? Yes, it is. But then there is this and condition. And condition means that if this whole thing needs to become true, this needs to be true as well as this needs to be true. So in my case, this part is becoming true where 75 is greater than 0. But is 75 less than or equal to 30? No, that makes it false. Because this part is false and this part is true and this is an and condition in between them. This means that this condition has basically fault. It has failed. So because it has failed, this means that I need to go back and repeat the stuff. So I go back and I again input the marks. This time I input something like 27. Now, if marks are less than 27, is 27 less than 0? No. Is 27 greater than 30? No. This means my 27 is in the correct region. So I won't be outputting any of this. I come up here directly and I check, is 27 greater than 0? Yes, it's true. And then is 27 less than or equal to 30? Again, that's true too. So both of the values are true. I'm good to go and I exit it. Now this basically allows me to ensure that the values which I'm inputting, it's within the correct region. So if sometimes a question comes up in your 15 marker or in a pseudocode that you need to keep on taking input until the user inputs a value between 0 and 30, you just need to implement this code. You need to make use of repeat loop until at the end, and you need to make use of this syntax where you need to check that if it's out of range, you need to output that you're out of range, and you need to set the condition up here some way that if it's not within the perfect range, you go back and you retake the input at the top. This logic which we just implemented up here is known as the range check. Just to give a quick recap about this and or statement, what this and means is that if there are two conditions, like let's say if Ramin grade is equal to A star, and there is one other student with the name of Ibrash. Ibrash also gets an A star. So if I put an or in between them, this or means that if either Ramin gets an A star or Ibrash grade is equal to A star, I'm going to give treat. Okay, I'm going to give treat. But if, for instance, Ramin grade sometimes, Khuda na khasta, God forbid, gets an A, but Ibrash grade is still A star, I'm still going to give treat. But if, let's say, none of them got an A star, like one got a B, the other got a B2. If both of them ended up with B, in that case, I will not be giving treat. So if either of the condition becomes true, I will be executing what's in there. All because we have an or statement. Or means if this is true or this is true. But if I have something like an and in between them, and basically means that Ramin should get an A star and Ibrash will get an A star, only in that case this has to run. Else it will not run. So if in this case, this is case when it's true, and this statement should also be true to run it up. If it's false, then it's not going to work. So that's just a quick recap for how and or needs to run up. So I can do this other stuff too that you need to keep on repeating the past papers until Ramin gets an A star or Ibrash gets an A star. Like for instance, I can create a scenario that the two of you, Ibrash and Ramin, they need to keep on doing past papers until one of them gets an A star. So one of them gets an A star. So either Ramin gets an A star or Ibrash gets an A star. So this or indicates that either this true gets true or this gets true. Either way, whatever gets true, you need to make this condition as true, and hence you can then exit the loop. And that is how you make use of the range check. Then we will be now moving on to the second check, which is basically the length check. What the length check does is that it looks and ensures that the data has an exact number of characters. So like for instance, the password scenario which I gave you, password needs to be greater than or equal to 8 characters. If it's less than 8, you need to tell them, bro, output incorrect password. Password length is smaller than 8 and you should re-input. How will I do that? Same thing. Like I have an example for you all up here too. So you need to write a program that asks for a password from the user and ensures that the password is greater than or equal to 8 letters. So what I'm going to do is I'm going to first of all ask the user output, please enter your password. And I'm going to use the same repeat loop the way I did before. You see now how I'm going to making use of repeat loops. So I'm going to use the same repeat loop and I would be like, okay, buddy, enter the password of 8 letters. So the person will input his password. Now, if I have a password like this, Mars123, and I want to count how many letters are there inside them. So one way of doing that is I have a function which has been declared beforehand by the examiner to make our lives easier, which is given the name of length. So if I create this length and in that length, I put the variable name, this will basically tell me how many letters are inside them. And this will also count if there is any space character. So like this Mars123 would be 1, 2, 3, 4, 5, 6, 7, 7 characters. Then this high space will be 1, 2, space will be counted as a separate character, 3, 4, 5, 6, 6 characters. So you see this length variable basically returns the number of characters in the variable and it also includes spaces in those number of characters. So I'm going to check that if the length of the password is less than 8, anything like 7, 6, so on, all the way to 0. If it's less than 8, you output that, bro, your out length needs to be at least 8. And then, just like before, you make use of an until condition up here that you need to keep on repeating this until when? Until this point where the length of it is basically greater than 8. So now if I enter something like Mars 1, 2, 3. This is 1, 2, 3, 4, 5, 6, 7. This is 7 characters. So this statement will become 7. Is 7 less than 8? Yes. So you say output length needs to be at least 8. And then is this 7 greater than or equal to 8? It's not. So you go back and again it says, please enter password of 8 letters. Then you again input something like Mars 1, 2, 3, 4. So now you check it and it's equal to 8. So 8 is not less than 8. Okay, 8 is basically equals to 8. People make this one mistake, but 8 is not less than 8. It's equal to 8. So this condition will not become true. You miss this and you come up to the until part, you check. Is 8 equals to or greater than 8? Yes, it is. So because this part has become true, I'm going to now exit the loop. And I'm going to exit the loop and boom, I'm done with my part. I have successfully ensured that the password which I'm going to use now, like maybe I might want to do something like output password later on or whatever I might want to do with it. This password is now of 8 characters. I have the certainty that it's of 8 characters. And that is how you generally check for if a specific set of letter or input or some variable is of a specific length, thanks to what the length variable function. So you should be familiar with this. Moving on, the third one, what do we call it, check, which we have in our syllabus, it's with the name of type check. This type check ensures that we all are aware that in our program, we can have multiple data types. We can have integers, which are basically numbers. We could have strings, which are basically letters and characters. We could have characters, which are just literally single words. We could have real, which could be like decimal points. We could have Boolean, which is basically true and false, or wherever we have two options. We're going to discuss this inshallah at the start of chapter 8 in great detail. But if I want to implement a specific type check to see that if the value which is being inputted, like let's say I only want to input integer values, how do I ensure that only integers are being inputted? So for that, what I can do is that if there is something being inputted like marks, I know that this should be an integer like 25. But there is this one problem that rather than writing 25 as a number, what if the person types 25 in terms of letter? Now my program was dealing with 25 divided by 2. Okay. So if it sees something like 25 divided by 2 this way, it won't understand. Why? It's going to give me an error. So rather than stepping into errors, we should give the chance to re-enter the information. And for that reason, we implemented the type check. How does that work? So the way is that if I'm inputting 25, one way to ensure whether this is an integer or not is by dividing that value by 1. I know, right, that if I divide 25 by 1, I'm going to get the same 25. I'm going to get the same 25. But if I do something like 20 by 1, my computer never understands what this means because this is not an integer. So my computer will give me an error. And the thing is, an error is never equal to 25. So I'm going to be implementing a condition where I'm going to divide the value by 1. And if it is equal to the value which I had at the first place, like I'm going to divide 25 by 1. If it is equal to the input of 25, you're good to go. But right now, if I have something like this, it's basically 20 divided by 1 equals to error. So is error equals to the original input of 20? No, right? It's not. So I would be like, okay, there is an incorrect data type inputted. So let's see this program to see how it works. So it says that write a program that asks an user for their number of siblings and ensures that the input from the user is an integer. So I'd be like, okay, buddy, enter number of siblings, and then you input this S count, which is my siblings count. And what I do is I'm going to check that if my sibling count is not equal to sibling count by 1, so like if my sibling count is, let's say, 6, and I divide this sibling count by 1, I know that this will also be 6, right? This has to be 6. If it's not equal to 6, like for instance, sibling count was something like SIX, so SIX by 1 is going to be an error. That's something the computer doesn't understand. So if it's not equal, error is not equal to 6. Remember, whenever you want to make use of not equals to, this is the sign. This is how you indicate not equals to in pseudocode. So if it's not equal to, because error is not equal to the 6 we have at the top, right? The input. So this basically is 6. And when I divide this 6 by 1, it's going to be my error. So 6 is not equal to error. Because they're not equal, I would be like, okay, incorrect data type, please re-enter. And if until the point when my input, which I've inputted, it's equal to S count by 1. So for instance, someone inputted like 7. So if 7 divided by 1 is seen, that's also 7. So if 7 is not equal to 7, you do this, but 7 is equal to 7. So I never run this and I just come to this until condition where I'm like, okay, S count, which was 7. Is it equal to 7 divided by 1? Yes, it is. It is equal to 7 divided by 1. So for that reason, I can clearly see that right now the data type which I've inputted, it's basically an integer. It's not of any other type. Now you might have some questions in your mind that, sir, what if it's Boolean? What is it strings? So generally, in exam, if it asks you, it's always going to ask you with the perspective of an integer. So you don't need to worry. It will be asking with the perspective of an integer in most of the cases. One other point here to note is that this statement where I'm dividing this with 1, this S count by 1, you can also write this using the diff function. Now what this diff function does is, diff says that you divide the variable by value. So what this does is, this basically evaluates into variable divided by val. Okay, so these two things are identical. So if you ever see in exam something like S count is not equal to div S count 1, this basically means that you divide S count by 1 and you're checking if this is not equal to the S count. So these two things are exactly the same thing. If you ever see this notation, don't be confused. It means the exact same thing as dividing it by 1. Perfect. Let's move on now to the next data check, which is basically my presence check. What does present check mean? Present check basically means that if I have, let's say, I might be filling a form because I might be going on a trip. And on that form, you would have seen that it asks for a name. And at that top, you have something like an asterisk, which says that this bar is compulsory to be filled. Like if I leave this empty, I don't write my name and I submit, I click on that submit button, it's going to give me an error. And it's going to be like, okay, this is compulsory. You need to fill this. How does my computer get to know that this bar where I need to input something, this has been left empty? How does my computer get to know this? For that, it implements a validation check, which is known as presence check. What does a presence check do? It ensures that a specific type of data has been entered and not left blank. So if something is blank, let's say name will be having my name. This way mouse, right? Because it's a string. But if it has nothing inside it and it's blank, then it's just going to be like this, quotation marks with nothing. Because this indicates that it's blank, it has nothing. Also, you can also not do something like this, name with quotation marks and with a cap, because now this indicates that you have a space character inside it, which is again valid. But if it's blank, this means that the name variable will just have quotation marks, nothing else. So what I'm going to do is, I would be like, okay, let's say I'm trying to check it for an email address, right? So I would be like, okay, please enter your email address. And then I'm going to make use of a repeat loop. I would be like, input the email. If this email is identical to just the quotation marks, which means that there is nothing inside it, right? Nothing inside it. Again, if you did something like this, it could be assumed that there is a space character. So don't leave a lot of space in between, write it this way, close to each other. If the email is like this means it's an empty string. Then I'm going to output email cannot be left blank. Please enter it again. And then I would be like, okay, you need to keep on repeating it until when? Until my email is not equal to empty string. So if my email is not equal to empty string, this means that then I will be able to exit the loop. But if my email is equal to empty string, I need to keep on repeating this until a person, the user, enters something which is not equal to the empty string I have up here. And that is how you basically make use of present state. Then the fifth one comes out to be as the format check. Now, back then when I was teaching there, I said that there is no pseudocode implementation. However, later on, I did find out one pseudocode implementation, which is that what a format check does is it's basically a check that looks if the entered input conforms to a specific format. So for instance, I am creating student ID numbers. So maybe one student might be STUD, which might indicate this is a student 123, student number 123, student number 124, student number 986, student number, let's say 787, and so on. It might go on, right? But every time there is a format being followed by the first four characters are STUD. So this ensurety that whenever I want to make use of STUD at the start, this is following a specific format. So now if I input something like MA13725, my program will give an error. It will say it does not match the format. Your format needs to have STUD at the start. And how does that work? For that, you're going to make use of substring function. We're going to discuss substrings later on, but the way it generally works for all those who might be aware of substring is that if I have a sentence, what I'm going to do is, if let's say input, there is an input, let's bring it up here. If there is an input for, let's say, name ID, I'm going to make use of substring to grab each of the letters. So I would be like, if substring name ID, comma 1 is equal to S, then if substring name ID 2 is equal to T, then if same substring name ID 3 is equal to U, and then if substring name ID 4 is equal to D, in that case, you can output that the name is correct. If not, elsewhere you can state that it is incorrect. So by making use of the substring function, you can basically implement the format check model. For anybody, once we are discussing this, inshallah, in chapter number 8, you guys could text me on my WhatsApp in that class so that I can show you an example for this too. Also, if you solve the October-November 2025 papers, inshallah, you will find a similar question which explores this concept of basically implementing a format check. So once you are solving that, just keep this in your mind that whenever they ask you to follow a specific format, you need to make use of a substring function, which will be going in this way. You need to compare each character one by one with the respective letters. So if it's compared that, okay, this is T, this is U, this is D, then at the end, you'll be like, okay, I'm good to go. It has matched the format, so it is according to the format. If it's not equal to this, you output, bro, it's wrong. And then you can make the until condition to see that, okay, if this is not and the blah, 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 you need to continue it. But main thing is, you make use of a substring function, which is something we're going to discuss in chapter number 8. So for that reason, I'm not going to be discussing it right now here. Moving on, the sixth validation check in our syllabus is the check digit. What's a check digit? It's something which has only been included there for the purpose of theoretical concepts. There is no programming implementation for it. Okay. And if let's say there is some sort of code given to calculate the check digit, you are not required to memorize it, not to be memorized. Remember, code for check digit, code for modulo 11, all of those have been given in the paper if tested. So if you are given a question to calculate check digit, the paper will include the relevant code for it. So you don't need to worry, you don't need to memorize the code. If you are, you're just wasting your time. The reasoning behind why check digit is included is so that you can understand why do we basically make use of check digit. So the check digit purpose is that it's basically an extra digit which is added to the end of number to detect if there has been any sort of errors while typing, scanning, or transmitting the number. So for instance, if I go to a shop, at the end of any item, you can see that barcode, right? And on that barcode, you're going to see something with the name of ISBN number. This ISBN number always includes one last digit as the check digit. And this check digit is basically calculated using the other values. So the way it works is, it basically, when you check it, when you, let's say, go to the counter and the counter person basically scans it up, the counter program basically adds these values and makes it go through a process to calculate the check digit. Now, the process is something which you don't need to memorize. If it comes in exam, the process will be given. And then eventually, this check digit will be compared with the check digit which is written at the end. If this value, let's say, comes out to be something like 4, 4 is not equal to 6. This means I made some error while reading the data. This means that the number which the computer understood were not this. And where can this happen? This could happen, like, for instance, I entered something like an incorrect digit, like rather than writing 5327, I entered like 5307. It could be a transposition error where I might be typing fast, so rather than writing 5037, I wrote something like 5307. It could also be possible that I might omit or add some extra digit, like rather than 55370, I wrote something like 537 only because I was in a hurry. And likewise, I can also make phonetic errors, which is basically, if let's say one of you is like, bro, you need to do 30. Okay, 30, 30, 30 in this action, right? 30. So if it's for me, one might say that, okay, it's 13, but the person was trying to say 30, 30. So maybe I might feel it to be a 13, but it's a 30. So errors like this can also happen. But whatever happens, whenever you input something wrong, it's going to ensure that this value gives you an incorrect answer. And when it gives you an incorrect answer, this incorrect answer, when compared with the correct check digit, tells me that an error has occurred. So this ISB number has only theoretical aspect to basically, if there is an error, the new check digit generated after will be different. And so this will basically tell me if there is any sort of an error in the code or not. That is everything out there. So that is everything you should be knowing for validation. These are the 6 types of validation in our syllabus, and I hope this is pretty much clear. Moving on, the next topic in our chapter number 7 syllabus is the verification. When we talk about verification, verification means that what if sometimes I want to create an account, it asks me for my password. So my intention was to input something like Mars123. But because I was in a hurry, because I had to go somewhere, I wrote something like Mars, and rather than 1, I wrote 223 mistakenly. Okay, mistakenly. Now, if I wrote this mistakenly, I thought I wrote 123, but it seemed to be that I wrote 223. Now, in a case like this, if I wrote something wrong, I would be cooked, right? Because I wrote a wrong password. So what programmers did was they always introduced something like re-enter password. So like if you entered some wrong password at the first glance, you can re-enter it. And now if you enter the correct one, like Mars123, my computer will give you an error. It will be like, bro, you entered 223 up there and now you're entering something else. So this does not match. Re-enter the password for the 2. This concept is known as verification, which basically checks if the data is accurately copied from one source into the another. And which also means that the data is the one which we intended to enter. So like if I intended to enter Mars123, but I went on with writing Mars223, then it should give me the error. It should tell me that, okay, bro, you went wrong. You should have inputted 123 rather than 223. This is really important. And this concept, which allows me to find out an error where I've mistakenly entered something incorrectly, it's known as verification. Now, how does verification works? So verification is like you input some value, then it verifies it. If the data which you have entered is identical to what you entered, that is what verification whole purpose is. And then if your data is identical to what you wanted to enter, then you do the process and output part. But how do you verify it? So there are 2 ways to do that. 2 ways in your syllabus. One way is the double entry, where it asks you to enter the data twice, and then you basically compare the 2 sets of data and see if they are different, then the computer computes an error. So like if I say enter password, I might enter like Mars123, and then in the re-enter one, I might do Mars223 mistakenly. So now the computer will compare them, and if they are different, it's going to give me an error. So if I have to see this in terms of pseudocode, I can say like ask the user for a password and implement double entry. It's just going to say double entry, or it might say verification. Either way, whatever you need to do is you need to first of all ask for password. Then you're going to say repeat input pass1. So you input the password at the first point, then you output and you say re-enter the password. Then you input pass2. which is my second password. Then I check if the password 1 is not equal to password number 2. I'm going to output, buddy, the passwords don't match, re-enter. Then I'm going to end the if statement and I'm going to keep on repeating this whole thing till when? Until my password number 1 is equal to password number 2, which means that if I wanted to input Mars123 and I also input Mars123 the next time, this means that I have successfully ensured that the value which I've inputted, it's the same as the one which I wanted to input. Clear? And that is what we mean when we talk about verification. And if you want to implement the same logic using a while loop, this is how you need to do it. So you'll be like, okay, while outside the while loop, you might first ask for password 1, then you will be again outputting re-enter password 2. And because while loop checks the condition before, you will be now checking the condition up here that while password 1 is not equal to password number 2, do this. Passwords do not match, re-enter. Then you again input the two values, and this keeps on going on until when? Until this pass1 is equal to pass2. Or in other words, I can say when this condition becomes false. The moment this condition becomes false, you exit the while loop as mentioned earlier in the class. And that is how you implement the double entry method. The second way is that you do a screen visual check. Where what happens is that, let's say you would have seen Food Panda, right? So in Food Panda, what happens is you place an order. And the moment you place an order, at the end on the screen, you get something like this: your order, blah 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 blah. Like I can say Veshi burger from JJ, then I might say like something else, and then it says confirm. So this is another verification. Even though I might have pressed that place order button, despite that, it came up and said that you should reconfirm it. Why? Because what if I made a mistake? So this check where something visually comes up on my screen and it asks me to confirm it manually, it's known as a screen visual check and is a type of a verification check. So this is basically a manual check for the user who is entering the data. And when the data is entered, the information is then presented on the user screen, and then the user is going to confirm is that it's the same or not. Like if, for instance, I enter a password, okay, I enter some password, Mars123. So on the screen, it's going to come up as you entered Mars123 as the password. Is this confirmed? Yes or no? So if you press yes, so it has verified. Yes, it is. If no, okay, you made some mistake, you can change it. So there isn't any pseudocode implementation for this, at least I haven't seen it, but you should know that there is this screen visual check, which basically has this description. Now, in your chapter number 7, a few topics have been like linear search, bubble sort, trace table. I deliberately took them out. I'm going to discuss them once we have discussed chapter number 8 in great detail because those are a bit relevant. But now we are done with all the verifications. We are done with all the verification and validation topics. And to be honest, we are done to an extent where if I give you a paper number 2, you should be able to score at least 35 to 40 marks out of 75, inshallah. Okay, even if not 30 marks out of 75, inshallah, easy. And now let me see how much of chapter 7 is left, because then, okay, I guess this marks the end of chapter 7. Let me recheck. Flow charts, yeah, okay, perfect. So continuing, if you remember back when we were discussing the program development life cycle, in that we studied one thing, that we will be testing the program with data to see whether it works the right way or not. So when I basically have to create a program, I'm always going to test it with some sort of data, which means that I have to identify a problem, then I write the relevant pseudocode for that algorithm, and finally I test it. But I'm going to test it with multiple data types. How? I'm going to test it with value which it should not accept. I'm going to test it with values which it should accept. I should test it with multiple sets of data to see, does it operate the right way with whatever the value user inputs. So for instance, if I create a program like this, input num, if num is greater than 0, you output positive. If num is, then you add 2 into num, and then you output negative if it's not. So what's happening? It's basically a program where you're taking some value as an input. So it's supposedly going to be an integer value. So I'm going to test my program that if I input something like string, if I input something like 9, does my program give an error or not? Does it give an error or not? Because this value is incorrect, it should give me an error. It should be rejected. So when I say that it should give me an error, when talking about this in the topic of test data, you say that the value should be rejected. So if I input something like a string for an integer variable, this means that this value should be rejected. Likewise, I'm going to test it that, okay, if I input something like 7, is 7 outputting positive or not? If it is, this means we are good to go. Likewise, if I might want to input something like, okay, in this case, those might not be applicable, but you get the point, right? We're going to input multiple different types of data to see whether my program will be accepting it or not. So if I have to give you a few examples, the types of data in our syllabus are 4. One is the normal data. Normal data is the one that is generally accepted by the program, and it is something which the program can handle during regular use. This is the correct and accepted data, and the program in this case should be producing correct result. For instance, if I input something like an 8. So 8 will output positive, which means that my program is working perfectly fine. Then the second type of data is known as abnormal data, and abnormal data also has one other name as erroneous data. So if you see erroneous data somewhere, do know that you're talking about abnormal data. And what abnormal data is, that it is the one which is not acceptable by your program because it is invalid or it is outside the range. And so if if it's something, it's basically for the purpose to see if your program handles stuff the right way or not. So like if I have a program which works in a way, if num is greater than 20 and num is less than 50, output high. So in this case, the acceptable value is what? It's something between 20 and 50, right? It's something between 20 and 50. So if it's something between 20 and 50, the acceptable value will be known as the normal value. But any data which is not acceptable, like something like a 0, maybe something greater than 50, like 75, these two are not acceptable. Anything that's not acceptable will be an abnormal value. Abnormal value. Let's also add an equals to sign, okay? So that num is equals to or less than. Likewise, we also have two other types of data. Those two data are extreme data and boundary data. And extreme data basically is the smallest and the largest acceptable value within a range. So for instance, if I'm creating this program, my program should be accepting the least acceptable value. What's the least acceptable value? It's this, that my program should have a value between 20 and 50. So 20 is the least acceptable value, and likewise, it should accept the greatest possible value, which is 50. So I'm also going to test my program that sometimes a person might make a mistake that they might agree with 20 to 50, but they do not include these terms. Like the way I did it before, I just placed these signs, right? This meant that the number should be greater than 20. So 20 is wrong in that case. So I place that equals to include that 20 is an acceptable value. So I'm going to be testing my values with these extreme largest and smallest values too. And these values which are extremely at the boundary of 50, boundary of 20, like the largest and the smallest boundary, is known as the extreme data. One point here to note is that extreme data will always be accepted. It's the largest and the smallest acceptable value within a range. And it works to ensure that the program works correctly at the extreme edges of a valid input. So for instance, if a program is going to ensure that a value is taken between 10 to 100, usually in program, they use the keyword inclusive. Inclusive means that 10 and 100 are also included in the correct region. So it's within the correct region. So 10 and 100 are within the correct region. If I have something like 10 and 100 within the correct region, what's the greatest acceptable value? 100. What's the smallest acceptable value? 10. So these two end up to be my accepted values, and they are known as extreme data. Just like that, we also have something with the name of boundary data. What's a boundary data? Boundary data is basically those values which are exactly at a specific boundary, either at the extreme higher boundary or at the lower boundary. So a boundary data exists at each boundary, where at every boundary, it's the value itself, like 10, and one value which is outside the range. So like in this case, 100 and 101. So one value in the boundary data, like for instance, if I take this example of 10, one is going to be 9, and the other is going to be 10. Let's keep it just 10. So in this case, one value is going to be accepted, the 10 one, whereas one value is going to be rejected. So boundary values is basically tested to see that if I'm making a program, it should accept 10, but the value which is next to it, which is exactly at the boundary, does it also reject that or not? So I tested one with the correct value, which is 10, which should be accepted. But then I also tested with the next closest value, which is 9, which should be rejected. Why? Because 9 is not in the range. So a boundary data are basically values just inside and outside the valid range. And it is used to test the program if it correctly distinguishes between valid and invalid input or not. So for instance, if it's for 0 and 100 between, so 0 will have two boundary data, -1 and 0. One is accepted, the other is rejected. And for 100, 100 is going to be the accepted one, 101 is going to be the rejected one. Now, if in an exam they give you a question to tell us a boundary value for a value between 0 and 100, all four of these values are the answers. So you can write -1, or you can write 0, you can write 100, or you can write 101. However, I would recommend that you write the value which has to be rejected. So if it's between 0 and 100, I would recommend that if it asks you for boundary data, write the answer to be something like 101 or like -1. Why? Because generally this 100 is also my extreme data, right? This 100 or like this 0 is also my extreme data, because these are the greatest and the smallest acceptable values. So rather than confusing this to be within the extreme value, it's better that when they ask you for boundary data, write the rejected value. So 101 or -1 rather than 0 or 100. Even though this might be correct, but it's better to go with the rejected data whenever they ask you for the boundary data. And then we have the logical operators, where what happens is that we have three types of logical operators. One is the and one, which I just said that both condition needs to be true for something to happen. Like if age is greater than 10 and age is less than 20, then do something. Or is when one of the two condition needs to be true, like we can say if topical or you are doing past paper, output that you are doing good. Not is the third type of operator, which basically reverses the value of a specific Boolean variable. So like if there is a variable present which is storing the value of true, then saying something like not present basically means that does the variable present have the value equals to false? So if I do something like if not present is equal to false, then you output very bad. Say, so it basically says that if I make use of not within a specific conditional statement, not basically reverses the state of whatever is in there. So if it was true, it converts it into false. If it was false, it converts it back into true. So currently present is true. So if not present is equal to false, this basically means that if this is false is equal to false, because this true will become false due to the not operator, we're going to output very bad. Likewise, if there is a switch which might have the value true and I do something like not switch, this is going to flip the value. So now if I output something like switch, so it will not be having the value true. It's now going to be having the value false inside. So this is how it generally works for not operators. You should be just generally aware of how not, or, and works, because they are relatively very much tested in pseudocodes. And if I want to make use of it further on, I can say if not switch is equal to false, output light off. So I can say that if switch is equal to true, so if you do it not with it, so if false is equal to off, you can output light off. If switch is equal to true, you might say output light on. And that is how you make use of not operator, or operator, and operator. And with that, this is another practice session for those who were a part of our May-June 2026 batch. Every weekend we used to have an extra class for the what do we call it, practice session. So those students were pretty much trained with possible questions. And this basically marks the end of our today's class. We're going to do this flow charts plus chapter number 8 in some other class, but we sort of covered up chapter number 7, alhamdulillah, in great detail. Also alongside this, my past paper session is going on. If anybody might want to join in, because they are unable to solve any sort of an exam paper and they're literally shocked and they're unable to do anything at all. So in that case, you can join in my past paper session. I'm going to be ending the registration form closely. But if you want to, what do you call it, want to register, you can let me know in the group. You can reach out to me in my DMs, or you can also reach out to me on Instagram, and I can share the patch, registration form, or I can share the details if you want to join in, and we can have a discussion on that later on. But that marks the end for me, because I'm cooked, spoke all the way for the last 2.5 hours. Gala mera mar gaya, literally cooked. But I'm turning on the chat box to see, just let me know, was the session helpful or not? Just a few. Sir, oh, bye. Sir, will you share the file you were showing all this time? Yeah, everything will be shared. Don't worry. I'm so glad to know. I'm so glad to know that it was helpful, guys. I'm so glad to know. Inshallah, I'm gonna, sir, group kaise join kare? So if you guys do one thing, go to my Instagram. I am gonna rewrite my Instagram up here again. It's with the name of Code Catalyst. Okay, CODE Catalyst. I'm going to create a new group tonight, inshallah, because we have already two groups, but the capacity have been met for both of them. So I'm going to create a new group, inshallah, tonight, and you guys can add them in there. Agli class, इसी तरह कब होगी? Not sure. I don't know. Let's see कब करते हैं, but we will be having it. So thank you so much. That was really, yes, the recording will be shared. Don't worry, recording will be shared. Everything in chapter number 8 will also be covered in great detail. But this marks the end of everything. Sahi hai? And with that, my website, okay, don't worry, I'm going to reset the server. I had a few changes being implemented there. I wanted to, what do we call it, change the 15 markers code a bit. So for that reason, it's not working. But let me check. The website should be working though. Codecatalyst.versal.app. So yep, it is working. It's perfectly fine. So you guys should follow my YouTube channel too. I have shared a lot of resources there. If anybody might want to revise the entire chapter 7 and chapter 8 in great detail, I have everything available on my channel. Okay, you can just watch that and you'll be good to go. So my YouTube channel is also with the same name of Code Catalyst, but I'm gonna, what do we call it, send the link. I'm gonna send the link. Here's the link. As for if you want to access my notes, you can do it this way. Let me show how you can do it. So this is my YouTube channel. You can find multiple stuff up here. Chapter 3, a lot of resources, topical stuff and all that stuff. But then up here, I have my your website. You come up to Code Catalyst to app. This is the whole website. Up here, you can go to the resources section. Okay. And in here, you can find these revision notes. You just open this folder, access all notes, and you're going to go to this Google Drive. You can find all the notes for all the topics. So we were just discussing chapter 7 today, and in the next one it's going to be chapter 8. You can access these notes from here. Apart from that, if you want to grade your 15 marker, you can do it through one of our 15 markers AI grader. It has a few problems at this point because I'm was updating it a bit, so it might not be working for the next few days. But inshallah, over time, a lot of people have taken the benefit. You can try though. I'm not sure though. I did work on it. It should be working if anybody could try. You should just, what the way it does is that you upload the question paper, you upload the marking scheme, and you upload your answer, and then you grade it. It gives you a detailed feedback on what you can improve and all that stuff in there. Apart from that, WhatsApp community group, even though it might be full at this point, but that's the link. And of course, if anybody wants to join the past paper session, they can join it up here, or they can reach out to me directly for more details. Here's my TA number if you want to contact them. And if you want to open up the YouTube or Instagram page, that's our Instagram page. You can search for it. Okay. And of course, we share a lot of useful stuff, a lot of useful stuff. So do ensure that you follow us. And the recording will be, inshallah, available on our YouTube channel. That's everything for today, everybody. I hope this session was helpful and that you guys had the chance to learn a lot. Inshallah, similar session will be conducted soon too. Take care, everybody. Bye bye. Allah Hafiz. Remember me in your prayers, and see you guys, inshallah, in the next class. Allah Hafiz.